What if the most consequential chapters of Earth's story were written not across its continents, but in the shadowed margins of its oceans? What if entire human narratives, cities, economies, philosophies had been built upon land that now lies beneath waves? Or even earlier, had been claimed and then consumed by forces so vast they leave behind only a chemical whisper in layered mud? That question hangs at the edge of human curiosity, like a distant light seen briefly through fog, barely there, nevertheless irresistible. More than 70% of the planet's surface is water. That simple number carries with it a cascade of implications. It is an invitation to humility. It is a reminder that what humanity can walk upon, the continents, the plains, the mountain chains, is only a fraction of this blue world's skin. Beneath the currents and the tides, an archive stretches, deep and stubbornly quiet. Much of it has not been read. Much of it has not even been touched. The ocean is both a vault and an eraser. It can entomb and it can obliterate. It can preserve by sealing things away under layers of silt and anoxia, and it can recycle, dissolve, grind, and carry evidence until the trace is gone. To think about lost civilizations beneath the sea is to think simultaneously in two scales of time. On the human scale, centuries and millennia hum with biography and accident. People build a village, carve stones into temples, lay down harbors, and within a few generations, their place names and genealogies can be forgotten. On the geological scale, epochs telescope the events that shape coastlines, glacial ice that traps oceans, then retreats, slow tectonic motion that raises and lowers land, the steady deposition of sediments that buries what was once exposed. The interplay of these clocks, fast human time and slow Earth time, creates the conditions for both preservation and erasure. The continental shelves, the gentle slopes that extend from coastlines into the first stretch of ocean, are where the two scales most visibly intersect. Today, they are submerged plains of sand and mud, bathed in light and life to varying depths. During the last glacial maximum, roughly 20,000 years ago, the sea level stood many tens of meters lower. At that time, areas that are now shallow seas were dry land, river valleys, tundra, forests, and human habitation. Some of these drowned landscapes are not speculative. The North Sea holds the memories of Doggerland, a Mesolithic landscape that connected Britain to continental Europe and that yielded archaeological finds when fishermen's nets dragged ancient bones and reworked hearthstones to the surface. Such discoveries confirm that human places can become ocean floor, sometimes with artifacts preserved in cold, oxygen-poor sediments. But preservation in the marine context is capricious. The same forces that conceal objects in anoxic mud, cold, organic, rich depositional environments are local and fragile. Currents can uncover and scatter, wave action and storms can break structures into fragments that muddle into indistinct debris. Chemical conditions at the seabed transform materials. Iron corrodes differently under salt and pressure. Pottery may survive where timber rots. Organic fabrics and wood are particularly vulnerable unless they are quickly buried in an environment that excludes oxygen. The sea is rich in organisms that consume and recycle organic matter. Even bones and wooden frames can be gnawed, bored, and chemically dissolved. The result is a fossil record biased by materials and context. Stone survives better than flesh. Ceramics better than textiles. Isotope signatures better than ephemeral art. Further complicating matters is the planet's habit of recycling itself. Oceanic crust, is born at mid-ocean ridges and consumed into the mantle at subduction zones. This tectonic turnover means that places that have been seafloor for hundreds of millions of years are rare. Most ocean crust is young compared to continental crust. If a civilization had existed on crust that has since been subducted, its physical traces would have been dragged into the mantle, subjected to pressures and temperatures that destroy the artifacts of surface life. That is a blunt geological constraint. Pre-volcanic seafloor records are, in effect, perishable at a planetary scale. It is a reminder that not all ancient histories can be discovered simply by looking down. Yet loss is not absolute. The ocean has preserved astonishing things. Shipwrecks, for example, become time capsules when conditions prevent decay. Chemical signatures in sediments can record abrupt changes. Layers enriched with soot could indicate large-scale burning. Spikes in certain isotopes might signal dramatic volcanic eruptions. Or shifts in carbon cycling. Organic molecules trapped in mud can reveal the presence of crops, of diets, of pastoral economies. In certain anoxic basins, materials normally susceptible to decay are conserved in forms that allow careful reconstruction. The sediment column is a slow-motion recorder. Its strata, a stacked set of pages, each bearing the imprint of climate, chemistry, and life at the time of deposition. When contemplating the possibility of lost civilizations under the sea, it is tempting to slip into myth. Tales of submerged cities have always occupied human imagination. They are stories of hubris, of nature's sublime power, of poetic justice. Those myths matter less as literal accounts than as cultural responses to the unsettling idea that the ground beneath one's feet might vanish within a lifetime or two. They frame the human relationship to transience. In every age, coastal societies have known the precariousness of the shoreline. Storms rearrange the sands, rivers change course, storms and tides take and give. That visceral knowledge has always shaped architecture, ritual, and storytelling. Speculation must be tempered with method. To ask whether an ancient industrial or urban civilization could have existed in deep time is to pose a query that science can approach, even if it cannot answer definitively. Empirical constraints suggest a narrow set of possibilities. For one, the age of the seafloor and the dynamics of plate tectonics make very ancient seafloor civilizations unlikely to have left retrievable artifacts, unless their remains were somehow transferred to continental margins or buried in long-lived basins. For another, the durability of different materials means that certain markers of advanced activity, metals, ceramics, stonework, would be more likely to survive than ephemeral art forms. But even metals can be cheated by chemistry. Iron rusts and blurs into sediments. Copper alloys can corrode into patinas. That obscure manufactory. There are, however, other signatures to consider. Global fingerprints that an industrial-scale society might leave that are not dependent on intact potsherds or standing architecture. Increasingly, scientists speak of stratigraphic markers, discrete changes in sediment chemistry that reflect abrupt shifts in biospheric processes. For example, a large perturbation in atmospheric composition could be recorded as a change in carbon. Isotope ratios preserved in marine sediments. Widespread use of certain materials could deposit rare elements or synthetic compounds into the sediment column. Nuclear activities, had they occurred in some ancient past, would leave isotopic anomalies of certain radionuclides. The modern era's fallout is already being traced in sediments and ice. Cause as a clear signal. Likewise, Plastics, conspicuously resistant to biological degradation, persist in the ocean and are becoming part of the fossil record of this era. Extrapolate those ideas backward in time, and one finds a conceptual space in which a past technological society might have left. Detectable if faint traces. The detective work to find such traces is itself an exercise in humility. Ocean exploration has improved dramatically. Satellites map sea surface heights, and multi-beam sonar paints contours of the sea floor with increasing resolution, but large swaths remain little more than fuzzy impressions. Deep ocean basins are poorly sampled. Sediment cores are precious because each represents only a tiny, vertical slice through a vast horizontal archive. The work of coring, mapping, drilling, and chemical analysis is painstaking and expensive. It also requires interpretation, and interpretations can be slippery. A spike in carbon in a given sediment layer might indicate a human cause, but it might also be a natural event, a volcanic eruption, a large-scale wildfire ignited by lightning, or a rapid shift in ocean circulation. Distinguishing human agency from natural variability often depends on converging lines of evidence, multiple independent signatures that together tell a coherent story. There is also a non-scientific psychological dimension to this question. The possibility of finding a lost civilization beneath the sea provokes a cocktail of emotions: awe at the scale of time and the richness of possible histories, sorrow at the thought of entire cultures erased, a sharp thrill at the detective possibility of recovering bones of a story long thought ended. It brings humility, the realization that what humanity knows is partial, that much of the planet's biography has been written in forms and languages humans have not yet learned to read. And it brings a certain existential vertigo, because these considerations invert the commonplace civic narratives of progress. If entire complex societies can be eroded from the geological record, then the continuity of an assumed path toward ever more enduring accomplishments looks more fragile. Yet the ocean is not merely a sapper of memory. It also shelters. Under the right conditions, its sediments can be a time capsule, sealing within them snapshots of atmosphere, biosphere, and chemistry. In anoxic basins, organic molecules are preserved. In laminated sediments, annual or seasonal records can be read like tree rings. The search for lost civilizations thus borrows from approaches used in paleoclimatology and archaeology. It looks for anomalies in otherwise steady records. A ceramic shard recovered from a dredged seabed would be extraordinary, a global isotope signature that cannot be explained by. Known natural processes would be profound. The sea's concealment also demands new modes of imagination. If a civilization left no durable monuments, if its architecture favored wood, if it left few large-scale mining signatures, if its population numbers were modest, then its traces would be subtle and require different strategies to detect. Perhaps the most telling residuals would be changes in ecosystems, the sudden disappearance of certain species, the abrupt introduction of domesticated crops into regional pollen records, or unusual concentrations of animal remains tied to new hunting patterns. The challenge is seismic in its implications to find lost civilizations in the oceanic archive. Science must be prepared to ask questions at the margins, to look for patterns of small, converging anomalies rather than for the dramatic silhouette of a submerged skyscraper. This is not an exercise in romantic fantasy, but in methodological possibility. The ocean sciences already use sediment cores to reconstruct human and climatic histories spanning millions of years. They have recovered DNA from sediments that reveal past ecosystems. They have traced chemical isotopes that mark abrupt climate shifts. They have detected microplastics and chemical pollutants that narrate the onset of industrial activity. Layered together, such approaches sketch a feasible path to detecting a past society. If such a society left discernible imprints within the sedimentary record, and if those imprints were not erased by the slow, relentless work of geology, the story is also a mirror held up to the present, contemplating how easily a civilization could be submerged and forgotten asks, in quieter terms, what legacies the current global society will leave in the stratigraphic record. It reframes questions of stewardship and temporality. The ocean's capacity to erase is a cautionary tale. Built environments, if dependent upon fragile coastal conditions, can be transitory. Human-scale efforts that disregard the slow but powerful rhythms of tides, currents, and tectonics are, by the geological yardstick, ephemeral. Finally, the sea's dual role as conservator and destroyer yields a paradox that is both intellectual and emotional. The ocean hides history, and in hiding it, it deepens the mystery of existence on this planet. But that same hiding creates opportunity. Every coring expedition, every sonar map, every chemical assay is a page opened in the ocean's logbook. Each reveals a fragment, sometimes unremarkable, sometimes startling, of the complex interplay between life, climate, and geology. As the narrator of this longer inquiry, the speculative documentary that tracks from question to method to evidence continues. The opening question remains unresolved and, in that irresolution, compelling. The ocean can be an eraser of civilizations and a preserver of a different kind of memory. To answer whether lost civilizations lie beneath the waves will require patience, interdisciplinary craft, and a willingness to see traces where they are faint. The sea is vast and older than human ambitions. It hides histories by default, by depth, by chemistry, by motion. But it does not hide them absolutely. The remainder of this exploration will ask not only whether such civilizations might have existed, but how, in practical and scientific terms, their faint signatures might be sought, interpreted, and understood. For now, though, the question is enough. The ocean conceals more than it reveals, and that fact alone reframes the human sense of time, presence, and possibility. Consider a thought so simple it almost slips past attention. Memory can be wet. The planet's capacity to remember is not confined to stone or carved monuments. It is encoded in the slow, patient accumulation of mud on the seafloor. If continental landscapes are like diaries scrawled in pencil, vulnerable to erasure, smudged by wind and rain, the deep ocean is more like an archive bound in oilskin, folded and tucked away where light and oxygen rarely intrude. Under certain conditions, time itself becomes a preservative. The deep sea keeps fragments for a long time, for tens of thousands of years, sometimes even longer. The sedimentary blankets that settle on abyssal plains, continental shelves, and the floors of restricted basins can lock away biological matter, chemicals, and physical debris. The mechanics are straightforward and ruthless. Particles drift down from surface waters in what oceanographers call marine snow, dead plankton, mineral dust, microscopic shells, and episodic events such as floods, storms, and underwater landslides add pulses of coarser material. Each drop adds a new page to a nearly continuous record. Where oxygen is low, where microbial decomposition is throttled, these pages are seldom rewritten. This is where the ocean diverges from the familiar erosive regime of land. On the continents, weathering is a chorus of forces. Wind abrades, rain dissolves, roots pry apart. Rock, frost heaves and shuffles sediments by cycle upon cycle. The daily assault of ultraviolet light, microorganisms, and fluctuating moisture levels acts like an impatient editor, continually revising and erasing traces. Even humans' greatest structures succumb. Timber rots, metals corrode, artworks fade. Only in special terrestrial circumstances, dry caves, deserts, peat bogs, or perennially frozen ground, does the land offer the kind of stability that yields long-term preservation. The ocean, by contrast, can become a silence so thorough that decomposition stalls and records are conserved. Not all marine settings afford this silence. The difference between a well-preserved layer and a palimpsest of smashed and mixed detritus depends on a handful of environmental variables. Oxygen is paramount. On oxygen-rich bottoms, a bustling community of worms, bacteria, and burrowing creatures churns and digests organic matter in a process called bioturbation. That churning blurs layers as a restless reader smudges ink on a parchment. In oxygen-starved environments, anoxic basins, stratified fjords, or deep depressions isolated from bottom currents, microbial decay slows dramatically. Organic matter, from the smallest algae to fragments of wood or bone, can be locked in place and sealed beneath anoxic mud. In such places, laminations. Thin, undisturbed layers remain intact, each lamina an annual or seasonal note in the record, comparable to tree rings. These fine laminations capture subtle variations, blooms of phytoplankton, pulses of riverine sediment, spring freshets, the dust of distant deserts carried on winds. The chemistry of the seabed also writes into preservation. Sulfide-rich conditions promote pyritization, where iron and sulfur combine to turn organic remains into iron sulfide minerals. Sometimes this process can fossilize soft tissue or wooden structures by replacing organic molecules with mineral equivalents, less as mummification and more as a mineral echo of former forms. In other locales, the presence of clay minerals and rapidly deposited fine-grained sediments can quickly bury and isolate objects. From physical disturbance and microbial digestion, cold temperatures in deep waters slow chemical reactions and microbial rates, further aiding long-term survival. The interplay of pressure, salinity, and redox chemistry dictates whether a wooden plank dissolves and skews into the mud or survives. A readable remnant of human craft. The archive is therefore heterogeneous. The Baltic Sea, for example, where salinity is low and bottom waters are often hypoxic, has preserved vessels and wooden artifacts for centuries and even millennia. In the Black Sea, laminated anoxic sediments have sheltered pollen, plant fragments, and even wood from ancient coastlines. In restricted Mediterranean basins, sapropel layers, dark, organic, rich deposits formed during intervals of reduced oxygenation carry concentrated chemical and biological records of past climates. These are not uniform safes, they are vaults with specific locks. One must find the right door. Reading that archive is an exercise in delicate, almost reverential technique. The tools of inquiry arrive in observation and extraction. Multi-beam sonar sketches the seafloor's topography in sweeping mosaics. Sub-bottom profilers reveal internal layering like an X-ray of a buried manuscript. Corers, piston, gravity, box retrieve pencil, thin cylinders of mud that are then split and examined. A core is a rolled timeline. Its outer surface is photographed. Its interior is sliced for microfossil counts, geochemical assays, and DNA extraction. X-ray fluorescence traces elemental peaks and troughs. Computed tomography sees through density. Isotopic measurements tease out past temperatures and carbon cycles. Each method translates silence into signal, transforming muted sediment into a story with chapters. The kinds of signals that survive vary by their physical and chemical nature. Hard, inorganically built objects, stone tools, ceramics, and certain metals can persist if they are rapidly buried and not exposed to corrosive conditions. Ceramics resist biological decay, though their context can be scattered. Iron and other base metals corrode in salt water, often producing patinas or leaving only chemically altered residues in the sediment. Organic artifacts, wood, textiles, leather are fragile, yet when trapped in anoxic mud they can be astonishingly well preserved, showing grain structure and tool marks that reveal manufacture. Beyond objects, molecular remains survive as biomarkers, specific hydrocarbon molecules from plant waxes, sterols from algae, even soot and polycyclic aromatic hydrocarbons that indicate burning at a given time. These chemical fingerprints can be as telling as a carved inscription, offering evidence of diets, fuels, and industrial inputs. The emerging field of sedimentary ancient DNA, cedar DNA, adds another layer of possibility. DNA fragments shed by organisms and trapped in sediments can persist for millennia under favorable conditions. Extracted and sequenced carefully, these fragments reconstruct past ecosystems, which plants grew nearby, which animals frequented the region, even the appearance or disappearance of domesticated species. Such reconstructions are not graffiti left by hands, but whispers left by bodies and microbe economies. They can reveal transitions in land use, the adoption of agriculture, or the spread of particular crops and animals, hints of human activity even when stone and metal are gone. Yet the ocean's preservative power is selective and capricious. Currents can scour coasts and remove evidence entirely. Storms can rework sediments into chaotic amalgams, and slow, corrosive processes leach or dissolve minerals over centuries. Even in anoxic basins, chemistry sometimes conspires against preservation. Acidification can dissolve calcareous shells, and sulfate-reducing bacteria can alter organic molecules beyond recognition. At larger scales, tectonic activity, subduction, uplift, and erosion redistributes and sometimes annihilates archives. A coastal plain hard-pressed into the mantle at a subduction zone will not leave a whisper for the next investigating epoch. The ocean is at once conservator and recycler. This duality preservation amid erasure shifts the question of lost civilizations from a romantic quest for sunken cities to a sober search for patterns in gradients and anomalies. On land, archaeologists often rely on discrete features, foundations, burial grounds, kiln sites. In marine contexts, investigators frequently look for fingerprints woven into the background signal. Unusual concentrations of certain metals, abrupt rises in charcoal and soot indicative of widespread burning, spikes in anthropogenic isotopes, the sudden appearance of domesticated plant DNA. The modern industrial era provides a template. Fallout from nuclear weapons left clear isotopic markers in sediments and ice. Lead from gasoline and metallurgy left chemical. Signatures, the sudden surge of plastics and persistent synthetic compounds will one day stand as unmistakable stratigraphic horizons. If an earlier technological society existed and was regionally expansive, it might have produced analogous anomalies, atypical elemental enrichments, compounds without natural analogues, or abrupt planet-scale isotopic shifts. Yet detection is constrained by sampling density and the vastness of the archive. Each core samples a narrow vertical column across an immense horizontal plane. Ocean mapping, while vastly improved over the past decades, still leaves large regions uncharted at the scale of fine stratigraphy. The probability of hitting a preserved pocket depends on knowing where to look: former shorelines, drowned river mouths, submerged caves, and low-energy basins where sediment accumulates and remains undisturbed. Bathymetric maps can indicate terraces, submerged paleochannels, and ancient deltas, topographic hints of places where people once camped, farmed, or built. Where rivers once flowed into, now submerged basins, sediments can choke with pollen, plant remains, and in some cases, the detritus of human habitation. These are places where the archive is thickest. Human emotions enter this scientific topology, not as actors, but as an interpretive lens. The impulse to find persistent traces is an expression of the same yearning that builds memorials and libraries to be legible to the future. When a core reveals a sudden band of soot, a spike in heavy metals, or the DNA of domesticated barley in a layer otherwise dominated by wild pollen, the reaction is a blend of excitement and caution. Excitement because such anomalies could indicate human agency at a particular moment in time. Caution because natural processes can mimic anthropogenic ones. Volcanoes, meteor impacts, or massive wildfires will also send soot into the sedimentary record. The scientist reader must be both sleuth and skeptic, compiling multiple lines of evidence until a coherent picture emerges. There is a poignancy to the whole enterprise. The ocean's archive underscores the fragile contingency of human memory. Where a coastal village once stood may now be a silent slope of silt. Where a field was tilled may be a buried band of altered pollen. The sediment column, patient and slow, reminds humanity that permanence is an illusion and that the planet's long-term ledger is indifferent to fame and small fortunes. Yet this indifference is not cruelty, it is scale. Deep time preservation is not a judgment, but a process governed by chemistry, physics, and chance. The investigator who reads these mud pages must therefore balance yearning with methodological rigor. Finally, there is a practical humility in working with the ocean archive. The search is expensive, technically demanding, and inherently probabilistic. Coring platforms, submersibles, geochemical assays, and ancient DNA labs are costly and limited in coverage. Interpretation requires interdisciplinary collaboration. Geologists, paleoecologists, chemists, sedimentologists, and archaeologists must weave their signals into a single narrative. The ocean will not yield its secrets to a lone voice. It demands collective patience and method. Yet, every recovered lamination, every anomalous spike in an elemental curve, every fragment of ancient DNA is a reminder that the sea is not merely a blanketing eraser. In the right place, under the right conditions, it is a slow-keeping ledger. For tens of thousands of years, sometimes more, the deep ocean can be a time capsule preserving echoes of climate, ecology, and, potentially, human activity. The lesson it imparts is both consoling and unnerving. Much can be lost, but much can also be conserved. If only one listens with appropriate instruments and asks the right questions. The ocean, then, is more than a physical barrier to the past. It is a library of wet pages and chemical inks, a place where deep time arranges memory in layers. The work ahead is clear in its ambiguity. Map broadly, sample deeply, and read with the humility of one who recognizes that a single core is a whisper from a vast chorus. Each lamination returned to the light is an invitation to reframe human history, not as an unbroken narrative rising inevitably upward, but as a set of episodes, some preserved, many erased, whose traces are scattered through mud, chemistry, and time. The archive waits not only to be found, but to be interpreted with an imagination governed by evidence. What if a story told in the cadence of myth was, beneath the rhetoric, holding an ember of real memory? That is the unsettling image that opens this chapter, a description written by an ancient philosopher, translated and retold for 2 millennia, might preserve the shadow of an event that reshaped coastlines and lives. Plato's account of Atlantis, an island polity described in the dialogues Timaeus and Critias, placed beyond the Pillars of Hercules, ringed with concentric canals and rich in metals and marvels, destroyed in a single day and night of misfortune, has lodged itself in the human imagination as a parable, a warning, and a puzzle. To treat that account purely as allegory is safe, to dismiss it entirely is perhaps too impatient. The more nuanced posture is to ask, could myth be memory in a particular form? A cultural repository for catastrophic environmental events that were otherwise unrecorded? Plato wrote not as an eyewitness chronicler, but as a philosopher and stylist. His description is precise in some respects and literary in others. The island is large, the architecture sophisticated, the people wealthy and organized. The destruction is sudden and absolute. Earthquakes and floods swallow the land, and the sea becomes the grave of the civilization. For readers across ages, those details have been read both as lesson and longed-for map. Yet context matters. Plato situated Atlantis as a cautionary foil to Athens, an ethical parable about hubris and moral decline as much as a geographical report. That dual nature-moral narrative and preserved detail creates the central methodological tension. Are some features of the tale literal recollections of a coastal calamity recast into archetypal form? Or do they emerge principally from storytelling conventions? Across the last 2 centuries, scholars, antiquarians, and enthusiasts have proposed numerous candidates that might have fed Plato's imagination. The eruption of Thera Santorini in the late Bronze Age is a frequent contender. The island's violent collapse and the associated tsunamis and ash fallout, dated around the 17th century BCE, left Mediterranean civilizations reeling. Archaeologists have argued over the reach of the eruption's effects, whether it contributed to the decline of Minoan Crete, how far tsunamis propagated, and what social dislocations followed. In this thesis, the physical violence of an eruption and consequent sea inundation might have been recollected in oral histories, and retold as a grand island destroyed by the sea. Other proposals look farther afield. The Black Sea deluge hypothesis imagines a relatively abrupt inundation of a low-lying, freshwater basin by Mediterranean waters around 500–600 BCE, a transition visible in marine cores as a shift from freshwater to marine microfauna and sudden changes in sedimentation. In this scenario, coastal communities would have been displaced as shorelines migrated inland, river mouths drowned, and marshes became open water. The memories of displacement and catastrophe could have travelled through centuries of retelling, accreting mythic elements. Similarly, the drowning of Doggerland, the now submerged plain that once connected Britain to continental Europe, was a gradual story punctuated by episodic floods and perhaps tsunami-like events that extinguished human occupation in places where peat and hearths once lay exposed to air. These geological possibilities share an important quality. They are empirical events with physical signatures. They left tephra layers, abrupt stratigraphic transitions, pulses of coarse sediment associated with storms or tsunamis, shifts in pollen and plant assemblages, and localized marine microfossils, indicative of sudden salinity changes. That is the optimistic side of the argument. If catastrophic inundation or volcanic ashfall underlies a mythic memory, then the Earth likely recorded it somewhere, in the layered mud of a basin, in drowned peat, in terrestrial sediments rapidly overrun by the sea. Yet the hurdles are substantial. The gulf between an oral tradition and a recoverable physical trace grows with time. Human memories are not photographs, they are narratives, reshaped by each retelling to fit cultural logics and concerns. A flood that removed a coastal village becomes a myth about a city punished for moral failing. Landscapes shift in ways the storytellers reinterpret. Add to that the confounding agent of geology. Coastlines move steadily with sea level rise after the last glacial retreat. Estuaries aggrade and migrate. Deltas build outward and then slump. Plate tectonics can obliterate shorelines entirely. Even if an event impressive enough to feed myth was real, its physical evidence may have been relocated, buried, or eroded beyond recognition. The methodological response is twofold. Seek places where preservation is most likely, and search for signatures that are plausible correlates of human catastrophe. Paleogeographers and marine geologists look for submerged paleo shorelines, terraces, beach ridges, and drowned river channels that mark where the coast once was. These paleolandscapes are often best preserved on continental shelves, where post-glacial sea level rise simply drowned a low-relief plain without subjecting it to the energetic abrasion found on open coasts. Modern bathymetric mapping, aided by multi-beam sonar and seismic reflection, can reveal terraces and channels that hint at ancient shorelines. In these geomorphic contexts, the probability of finding anthropogenic traces, middens, hearths, plant remains rises. The sedimentary record provides a second line of inquiry. Tsunami deposits, for example, have characteristic features. A pulse of sand or mixed coarse material transported landward over a usually fine-grained coastal plain, sometimes containing rip-up clasts and marine microfossils out of place for their surroundings. Ash layers from major eruptions are likewise identifiable, their chemistry matching known eruptions through tephrochronology. Pollen assemblages can record sudden shifts from terrestrial plants towards salt-tolerant species, indicating inundation. Ancient DNA extracted from sediments can reveal the presence or disappearance of domesticated species. None of these signals alone proves a complex urban civilization once occupied the drowned plain, but together they can suggest a landscape that changed abruptly in ways that would have been culturally traumatic. That is the essence of the cautious optimism, a multi-proxy approach. A coherent narrative emerges only when geomorphology, sedimentology, geochemistry, and biological markers converge. A tephra layer above a habitation horizon sealed by tsunami sand, coupled with a sudden and persistent change in pollen, and the introduction of domesticate DNA creates a stronger case than any isolated anomaly. Such convergence is what distinguishes a plausible memory from wishful projection. Still, cultural and textual analysis must temper geoscientific evidence. Plato's context was not only Mediterranean, it was Athenian politics and philosophical pedagogy. Atlantis functions within the dialogues as an ethical foil. Critics point out that Plato's dates, measurements, and cosmological detail do not align neatly with any known paleogeographic configuration. Moreover, elements of the description concentric rings of water, a palace of precious stone, an empire spanning the Atlantic are improbable as direct reportage. That suggests mythic architecture at work. Yet myth does not preclude kernel events. Cultural memory can enshrine a flood as a narrative of moral catastrophe while preserving outline details derived from actual geophysical phenomena. Beyond the technical matters lies a deeper anthropological point. Flood myths are cross-cultural. From the Mesopotamian epics to indigenous oral traditions, inundation narratives recur. They are not arbitrary. They often follow local experience of extreme rainfall events, valley dam breaks, tsunamis, or sea level changes that alter lifeways dramatically. The persistence of flood myths for millennia is thus less surprising than it might seem. Catastrophic landscape changes produce psychological and cultural trauma that is well suited to transmission. The image of a civilized hubris toppled by elemental powers is a cognitive container for events that exceed ordinary explanation. Yet even if Atlantis, as Plato described, it reduces to accreted memories of more mundane catastrophes, the cultural power of the story presses modern inquiry into a different question. What should be expected in the sedimentary record if a polity of scale comparable to classical city-states existed on a now drowned shelf? The discovery of a single elite residence or fortified enclosure would astonish. Chemical residues of large-scale metallurgical activity or peculiar isotopic shifts in carbon or lead across a widespread area would astonish more. Anthropogenic fingerprints left on the earth at scale, metals in soils, unusual concentrations of combustion-derived soot, shifts in nitrogen cycling visible in sediment isotopes are the kinds of signals scientists have learned to recognize as products of human activity in the Holocene and late Pleistocene. The search, then, is an exercise in matching expectation to preservation potential. If a Bronze Age coastal society engaged in widespread metallurgy near a river mouth that was later drowned, slag and heavy metal anomalies might have been sequestered in the delta's sediment. If a catastrophic tsunami transported cultural material into a basin with restricted circulation, anoxic conditions could preserve organics and prevent bioturbation, allowing laminae in which artifacts lie intact. Conversely, if a putative civilization relied heavily on perishable materials, timber, thatch, reed, the archaeological footprint might be muted and easily lost beneath waves and currents. That variance in preservation potential must govern both the optimism of the search and the humility of its claims. This is the place where the sea's dual nature, the capacity to erase and to entomb, becomes morally and intellectually resonant. Atlantis, as a memory, would mean a civilization's trace could persist in some form in the geological ledger. But it also highlights how much human accomplishment can be ephemeral. For those who look for Atlantis as a literal city of monuments, the lesson is simple and sobering. Absence of evidence is not decisive. Evidence of absence. The ocean does not keep its records in the same way as deserts or caves. It preserves selectively and erases wholesale. Finally, the story of Atlantis illuminates the human appetite to reconcile narratives across scales. The philosopher in Plato fused politics and cosmology to produce a story with moral force. Modern inquiry seeks to translate those moral and narrative structures into testable hypotheses about the deep past. The bridge between them is neither certain nor impossible. It is probabilistic and archaeological, a weaving of data and interpretation. To find Atlantis as a literal polity would be to rediscover a lost chapter written not only with stone and tile, but also in the subtle chemistry of mud. To find only evidence of coastal upheaval would be to accept that myth and memory often cohabit. The sea can wash away specific forms of a past civilization while preserving the dramatic shape of an event in cultural consciousness. There is wonder in that ambiguity, the possibility that a story told for philosophical ends could sit upon a substratum of ecological catastrophe invites a certain humility. Human narratives are both fragile and tenacious. They can shift forms, yet they may retain shadows of hard events shaped by wind, ash, and tide. The work of science in this terrain is not to vindicate romantic expectations, but to triangulate between text and terrain, between telling and tracery. It requires precise mapping, patient coring, chemical assays that read the palimpsest of time, and an interpretive restraint that recognizes the interplay of natural and cultural processes. In the end, Atlantis stands less as a location on a map and more as a question about how human societies encode environmental catastrophe into myth. It is an invitation to investigate where preservation is plausible, to listen for the signatures that a drowned landscape might hold, and to acknowledge that even the most elaborate myths can originate from real events refracted through generations of memory. The narrator of this speculative documentary holds that question as an operative tool, not to insist that Plato's island was real in the literal sense, but to accept that human history and Earth history are entangled in ways that complicate easy dismissal. To read mud and myth in tandem is to accept the planet's long habit of rearranging its own biography, and of doing so in a way that leaves both ruins and stories, sometimes separately, sometimes together, for those who know how to look. What if a city that once organized trade, law, ritual, and daily life along a coastline now lay asleep beneath a shallow shelf, its stones coated in silt and its temples silenced by salt? What if the shoreline that people oriented their calendars to, the harbor where merchants exchanged beads for copper, the sacred groves where myths were woven into politics, what if all of that slid beneath the sea, not as a single catastrophic vanishing, but as a slower, noisier process of drowning and forgetting? These are the images that gather around the submerged ruins off the coast of Gujarat, the site known in scholarship and legend as Dwarka, along India's western seaboard. Beyond the modern pilgrimage town that shares its name lies a sequence of discoveries that blurred the line between legend and strata. The offshore terrain here is complex, a continental shelf dissected by paleo channels, tidal flats that accumulate and erode with each monsoon, and a coastline that has been both patient recorder and relentless resculptor of human activity. In the latter half of the 20th century, and with renewed attention in later decades, marine investigations began to reveal things that, when read carefully, suggested that people had occupied the now submerged margin for millennia. The material hints are simple and ambiguous: stone blocks arrayed in alignments, walls of dressed masonry half buried in sand, anchors with holes drilled for ropes, ceramic sherds in stratified deposits, and concentrations of shell and bone that suggest human refuse rather than pure marine accumulation. These finds were made by many means: divers examining exposures revealed by storms, systematic surveys using side-scan sonar and multi-beam echo sounders, and sediment coring that captured the vertical record of environmental change. Each technique translated the quiet of the seabed into audible signals: sonar pulses that returned ridges where streets might once have run, coral extracts that revealed peat overlain by marine clay, radiocarbon ages that placed episodes of inundation at certain windows of the Holocene. The first visceral reaction to such discoveries has been a mixture of wonder and caution. There is a human hunger to map narrative onto these artifacts. A block here becomes part of a temple, a line of stones suggests fortification, a ringed anchor conjures a fleet. But scientific method requires a different discipline. Context matters more than charismatic fragments. Were those stones shaped by human hands, or are they erosional remnants? Do anchors indicate systematic anchorage or opportunistic mooring over centuries? How old are these materials in absolute terms? And does their depositional context match a human occupation horizon or a later colluvial deposit? The answers have rarely been simple. One of the best-known sequences of findings emerged from the area of Bet Dwarka and the modern town of Dwarka in Gujarat. Marine surveys, as well as targeted archaeological diving campaigns beginning in the 1980s, produced suites of materials that plausibly indicate shoreline activity across a wide time span. Stone anchors, some roughly U-shaped, others with holeworks, were retrieved from shallow bottoms. Dressed stone blocks lay in. Linear arrangements, pottery fragments of various fabrics were recovered and subjected to typological study. Radiocarbon dates taken from associated organic material, charcoal. Shell suggested episodes of human presence and environmental change during the late Holocene. These data invited one interpretive frame, a port and settlement system that eventually saw parts of its infrastructure submerged as sea levels rose and the coastline migrated. Yet the interpretive frame has always been porous. Dating marine contexts is technically demanding. Radiocarbon ages from shell material, for example, are confounded by reservoir effects. Marine organisms incorporate carbon with different apparent ages depending on ocean. Circulation and local inputs, meaning that a shell's radiocarbon age can be misleading unless carefully corrected. Organic remains trapped in estuarine peat or terrestrial soil can provide more robust constraints, but such materials are not always present, and the dynamic behavior of tidal regimes can redeposit cultural material across stratigraphic horizons, smearing the record. The result is that evidence for submerged urbanism in this region is best understood as a patchwork of indicators, some strong and direct, others suggestive but equivocal. Parallel to the archaeological record runs an older, more enduring form of evidence, texts and oral traditions. The Mahabharata and later Puranic texts recount the story of a magnificent city associated with the god King Krishna, a polity with palaces, canals and sophisticated urban order that was later submerged. For believers and historians alike, such narratives raise an intriguing possibility that cultural memory preserved a traumatic inundation that was later refracted through poetry, theology, and mnemonic convention. The existence of submerged masonry and anchors off the Gujarat coast provides a stage on which myth and geology might meet. But correlation is not causation, even if a coastline drowned in antiquity. The details are usually recast to suit moral and symbolic frameworks. The intellectual posture that governs the scientific reading of Dwarka's submerged record has therefore been one of cautious convergence. Sediment cores from estuaries and shallow basins near the site revealed sequences in which terrestrial peat or freshwater deposits were abruptly overlain by marine clays, classical sedimentary evidence for transgression, the inland encroachment of the sea. Microfossil assemblages recorded an increase in marine foraminifera and mollusk fragments where freshwater indicators had previously dominated. Geomorphological mapping, identify paleochannels and drowned beach ridges on the continental shelf, features consistent with a former coastline now submerged. When such independent lines of evidence align, geomorphology indicating a paleo shoreline, coring showing a sudden shift to marine sediment, and artifactual material concentrated at that horizon, the case for an episode of coastal abandonment and inundation grows stronger. Yet the question that follows almost naturally is broader and more unsettling. How many such coastal entanglements exist across the subcontinent's margins? If a port system had once fringed the shelf near modern Dwarka, then other shelf-edge habitations, microsites where people fished, farmed, and traded, may have been similarly lost. The gulf between pockets of preservation and the immense, often erosive contexts of continental margins means that only some places, under particular chemical and geomorphic conditions, will retain legible traces. Estuaries that have been rapidly buried by deltaic accretion, anoxic basins where organic matter is conserved, and sheltered coves protected from strong wave action are the loci most likely to keep a recognizable record. Elsewhere, waves and currents will have dispersed or recycled human residues into the wider sedimentary flux. This unevenness carries a human dimension. Archaeological attention tends to create narratives where they can be supported. Silence in the record can be read as absence. But absence may simply indicate poor preservation potential. The consequence is a skewed perception. A few well-preserved coastal complexes become emblematic of lost worlds, perhaps more central in public imagination than a much broader geographic distribution of ephemeral sites that left only faint chemical whispers. The risk is to extrapolate the existence of grand, urbanized polities from a handful of robust finds while ignoring the modest, perishable lifeways that nevertheless sustained human populations along coasts for millennia. Beyond methods and preservation lies the politics of heritage. Discoveries off the Gujarat coast have ignited interest not only among archaeologists but also within the public sphere devotees. Local communities, national narratives about continuity and antiquity, the interpretive possibilities of an ancient, submerged Dwarka dovetail with cultural memories and religious attachments, amplifying emotional responses. For some, submerged ruins seem to validate sacred histories. For others, they raise hopes of new chapters in the nation's past. Scientists, in turn, feel the pressure of expectation. The discipline's response tends toward procedural rigor, publish data, calibrate ages, test hypotheses, and acknowledge uncertainty. Yet these procedures play out within a social ecology where archaeology is simultaneously a mode of knowledge and a terrain of meaning. Technological advances have reshaped the search. High-resolution bathymetry paints detailed, three-dimensional images of the seafloor. Sub-bottom profiles show internal layering. Remote-operated vehicles allow careful examination of structures in situ without the disturbance caused by heavy divers, sediment. DNA techniques open new windows into past vegetation and animal use. In the Indian context, such tools have been used to re-evaluate earlier claims and to refine chronological frameworks. Where once a single survey might suggest a submerged town, a sequence of multidisciplinary investigations now demands correlated evidence across geomorphology, sedimentology, artifact analysis, and environmental proxy records before an interpretive consensus is entertained. Still, the emotional core of these discoveries is not merely in methodological thrill. There is a poignancy in the sensorial image of a coastline losing its human markers, hearths, and wells swallowed by tidal flats, Cays eroded until stone becomes an ambiguous rubble in a bed of mud, sacred spaces fading into the acoustics of the sea. These are not simply archaeological losses, they are erased orientations, markers by which communities had historically located themselves in time and place. The sea's encroachment is an agent of reorientation that reshapes cultural memory and the landscapes that anchor it. The Dwarka investigations also prompt a wider epistemic humility. If the western margin preserves a readable sequence of occupation and inundation, other margins may keep only faint chemical traces, a pulse of soot in a peat layer, an unusual concentration of copper in deltaic sediments. The sudden appearance of domesticate pollen followed by marine microfossils. The deeper lesson is procedural and philosophical. To understand lost coastal worlds, scholarship must embrace a plural toolkit, sonar and cora, pottery analysis and pollen counts, isotope geochemistry and ancient DNA, while remaining alert to the limits of inferences that can be drawn from fragmentary evidence. The sea does not yield its archive in clear narrative parcels. It offers fragments that demand associative imagination, not romantic reconstruction. There is also an ethical horizon. As sea levels continue to change, driven today by anthropogenic warming, modern coastal communities face a future that makes the submerged past urgent and resonant. The archaeological work offshore is not merely academic, it is a reminder that coastlines are living, shifting interfaces where human plans meet planetary processes. The resonance between past inundations and present risk invites reflection on stewardship, resilience, and the ways cultures encode catastrophe. Finally, the question returns to its opening image: how many cities? The answer is not a tidy integer. It is a probability distribution, a spectrum of preservation potential, and a record of human adaptation. Some coastal sites near Dwarka preserve stonework and evidence of structured maritime activity. Others are muted signals in the isotopic record. Many places that pulses of human life once made legible have been erased beyond recognition. The task for science is not to produce a definitive census, but to chart the margins where preservation is possible, to refine dating and contextual frameworks, and to weave together environmental and cultural proxies into narratives that are probabilistic, cautious, and humane. In that sense, Dwarka is both specific and emblematic. It is a locus where archaeology, geology, and myth intersect, a place where the sea's archives whisper of human presence and where the interpretive enterprise must balance hope with rigor. It suggests, not as an assurance, but as a possibility that there are other submerged human traces along continental margins, some awaiting discovery in protective basins, others irretrievably ground into sediment. The broader question is not only how many cities lay beneath waves, but how many lives, livelihoods, and cultural practices were reconfigured by the slow, powerful choreography of sea and shore. That is a question whose answer will emerge slowly from the patient reading of mud, stone, and chemical ink, and from an intellectual posture willing to listen to the sea's long and ambivalent testimony. What does it mean to find something that looks unmistakably made right angles, terraces, steps beneath the indifferent press of the ocean? What happens to a human impulse to redesign where geology is at work? The submerged terraces off the southern tip of Japan present precisely that question, an image at once arresting and discomforting. A stairway to nowhere that forces a confrontation between two kinds of time: the deliberate, short-span time of craft and culture, and the patient, enormous time of rocks and tides. The site, commonly called Yonaguni, is a collection of slab-like surfaces, sharp-edged ledges, and broad, flat platforms lying on a shallow shelf off the Ryukyu Islands. Seen from above, the formation suggests geometry, long linear grooves that meet at near right angles, wide benches that appear as successive levels, a central mass that can be read, if one leans that way, as a stepped pyramid. Close up, there are hollows and pits, channels, and what appear to be quarried blocks lying in accordant arrays. The overall effect is uncanny. A place where nature's take on rectilinearity seems to have crossed into a realm of intentionality. The first encounter with the site often proceeds via light and machines. Sonar swathes the seafloor in schematic grayscale. Multi-beam returns generate a low, resolute relief. Polylines on a screen become the scaffold for a hypothesis. Cameras, either tied to diving ropes or carried by remote vehicles, translate that relief into familiar lines and shadows. In those images, the terraces read like stages, each one a flat plane that opens into a vertical face. The drop between surfaces, clean and abrupt. The light slants across fractured edges, and the eye, trained by centuries of human design, is quick to tag the forms as artifacts. It is an act of pattern recognition so immediate it feels like truth. And yet the truth remains disputed. The temptation to assign authorship, humans versus nature, collides with a geological vocabulary that explains how rock fractures, how waves sculpt, how tectonic movement can uplift and then resubmerge a coastal platform. The Yonaguni Formation sits in a tectonically active zone, a place of uplift, subsidence, and vigorous wave action over millennia. These are settings in which wave-cut terraces can form, in which bedding planes and jointing in sedimentary rock create straight lines and blocky forms, and in which the ocean's erosive hand can accentuate perceived regularity by scouring softer material and leaving more resistant slabs. The natural explanation hinges on a series of processes that are common in coastal geomorphology. Sedimentary rock layered, jointed, and fractured by stress tends to break along planes of weakness. When such rock is exposed to the repeated battering of surf, processes of abrasion and hydraulic action exploit those weaknesses. Repeated cycles of wave-pounding detach blocks, and the remaining surfaces take on planar faces. Vertical joint sets that run at near right angles can produce blocky outlines and straight cleavages that read easily as corners. When a coastline undergoes uplift and then partial submergence, former wave-cut platforms become terraces beneath the sea. Each terrace representing a former sea level stand or structural bench carved into the rock. In some geological settings, these terraces align in ways that appear deliberate because the underlying jointing constrains the geometry. Supporters of a natural origin point beyond the macroscopic layout to smaller scale features. Scalloped erosional niches where hydraulically driven vortices gouge hollows, smooth. Polished bedrock surfaces where sand and pebble-laden water acted like sandpaper over centuries, networks of fractures that divide rock into rectangular blocks without any human hand. Comparative analogues exist on emergent coasts nearby. Terrestrial outcrops display the same orthogonal jointing and stepped morphology, proof that the processes at Yonaguni are not unique but rather local instances of common coastal physics. Yet the human imagination resists such neat closure. The alternative interpretation that the terraces are the ruins of a human-built structure, a megalithic complex drowned by rising seas, draws on the same visual cues that propel the natural argument. The apparent regularity of plan, surfaces that look dressed, what some observers describe as staircases, plazas. and fluted stones resembling pillars. Proponents of human authorship note the arrangement of certain blocks as if they were deliberately set, the presence of linear grooves that look too regular to be purely erosional, and a spatial composition that suggests plazas and processional ways. The idea that people could have fashioned large stone architectures along a coastline that later sank beneath the waves is not absurd in itself. Coastal communities have always built on shorelines, and rising sea levels during the Holocene did drown many such sites worldwide. The debate intensifies because the two readings, natural and anthropogenic, are not mutually exclusive in the sense of being easily separable by casual observation. Nature can produce highly regular forms, human activity can be obscured by natural overprinting. The challenge is one of signal and context. Is there material evidence that cannot be plausibly produced by natural processes? And does the broader archaeological and stratigraphic context support the existence of a culture capable of executing the architectural gestures implied? Answering that requires an interrogation of multiple lines of evidence, each with its own constraints. Stone itself cannot be radiocarbon dated. To anchor an alleged construction in time, investigators must rely on indirect dating strategies. Organic material trapped in sediment layers associated with the surface, encrusting marine organisms whose growth can be dated by uranium series methods, stratigraphic relationships to dated sea level curves and tectonic histories. Core samples taken from sediment pockets atop or between terraces can reveal whether a particular bench was emergent and soil covered at a given time, or whether it was simply eroded bedrock. Microfossil assemblages can indicate a shift from terrestrial to marine conditions, which in turn constrains the window in which human occupation might have occurred. What has been found and what has not matters. At Yonaguni, direct artifacts of indisputable human manufactured pottery sherds, worked stone tools in situ. Remnants of organic structures have not been recovered in abundance in contexts that convincingly predate the submergence. The material that exists often sits on top of the terraces or in talus at their edges, in positions suggestive of later deposition. Measurements of joint spacing and fracture networks correspond closely to what regional geology predicts. High-resolution mapping has documented how bedding planes and joint orientations match regional stress fields, a pattern more consistent with natural fracturing than with selective quarrying. Photogrammetric surveys show surface features whose microtopography, rounded corners at some scales, tool-like striations that align with erosional models are ambiguous at best. Still, the ambiguity is fertile. It reveals not only limits in the record, but the psychology of seeking origins. The human mind prefers narrative coherence. Given a form that looks like steps, it will instinctively construct a story about stairways, about ceremonies that climb terraces. That impulse is neither bad nor irrational. It is part of how meaning is made. But scientific method demands a different posture. Entertain the narrative as a hypothesis. Then dispassionately test it against the depositional record, the chemistry of encrustations, and the architecture of regional geology. That testing is familiar to marine archaeologists and geologists working across the shelf. Sonar and sub-bottom profiling map, morphology and stratigraphy, photogrammetry and structure from motion produce detailed three-dimensional surfaces, sediment coring samples, the vertical archive, petrographic analysis reads rock texture and fabric. Microstratigraphy and paleontology reconstruct environmental histories. Together, these tools can separate a terrace that was carved and used by humans before being drowned from a wave-cut bench that always belonged to the coastal machine. At Yonaguni, those converging methods have tended to favor a natural origin, but the final verdict remains a cautious one, because the absence of unequivocal human artifacts leaves room for doubt. The social and emotional heartbeat of the controversy deserves notice. Yonaguni is not merely an intellectual puzzle, it is a mirror for human longings. For proponents of submerged civilization ideas, the formation offers hope, proof that human complexity could be older and more widespread than conventional narratives allow. For skeptics, the site is a reminder that the planet is capable of producing forms easily misread as design. The tension between hope and skepticism plays out publicly in documentaries, in popular books, in tourism brochures, and in the quieter corridors of academic debate. The same visual cues that excite speculation also attract divers, photographers, and treasure seekers. Public fascination pressures the research agenda even as scholarship insists on rigorous methods. Yonaguni thus becomes emblematic of a larger methodological lesson articulated throughout the search for submerged human histories. The ocean's capacity to both preserve and erase is not binary. It preserves under particular chemical and geomorphic conditions, anoxic basins, rapid burial, or gentle, fine-grained accumulation that isolates artifacts from destructive agents. It erases by breaking, dissolving, and redepositing. It masks human intervention beneath sheets of biology and chemistry. A structurally convincing terrace is not the same thing as an architectural plan, what looks like a plaza in the play of light. And shadow may be a coincidence of fracture and erosion. Conversely, the lack of clear artifacts on an obvious platform may owe less to their non-existence than to their removal or concealment by natural processes. That ambiguity produces a specific kind of intellectual humility. The Yonaguni question does not merely ask whether a particular place is natural or cultural, it asks how humans interpret environment, and how scientists must temper narrative impulse with cautious inference. It asks what counts as evidence in a place where human and natural processes intertwine so closely that they become almost indistinguishable. It asks, too, how cultural desire for origins and continuity shapes the reception of scientific claims. There is practical work ahead that could sharpen the picture. Targeted coring across terraces and adjacent sedimentary basins could identify habitation horizons or sealed paleosols that betray terrestrial occupation prior to inundation. Uranium series dating of carbonate cements or encrusting organisms may bracket exposure times. High-resolution mapping of jointing and fracture density can test whether any linear arrays are outliers relative to regional patterns. Searches for associated lithic scatters on the shelf, concentrations of worked stone or fire-affected sediments would provide strong corroboration if found in stratigraphic position. And comparative work, looking at known human-built coastal structures of similar scale in geological contexts and seeing how they differ in microtopography from natural terraces, could provide diagnostic criteria. Ultimately, Yonaguni's principal value may be rhetorical and epistemic rather than declarative. It presses the deeper question, central to the larger inquiry of submerged civilizations. How does one read faint, ambiguous signals in a marine archive that is at once partial and protean? Yonaguni teaches patience. It insists on modesty before the rock and the sea, on a procedural generosity of evidence, and on an interpretive caution that balances wonder with method. The terraces under the Ryukyu waters are, in this sense, a parable. They show how quickly the human mind will move from sight to story, and how carefully science must move back from story to method. Whether those ledges are the vestige of an ancient plaza or a splendid example of wave-cut geometry, they underscore the central point. The ocean holds forms that can be read many ways, and every reading says more about present human questions than it does about a single historical truth. As the speculative documentary continues its sweep from the hush of sediments to the abrupt outlines on a seafloor, Yonaguni remains an instructive pause. It is a place where the boundary between artifice and geology is thin, where the desire to find continuity with a drowned past meets the patient arguments of stratigraphy and structural geology. In the light of that interstice, the narrator's voice softens not into surrender, but into renewed curiosity. The sea has made a shape that looks like a stairway. The human task is to learn, with as many tools as possible, what kind of time that stairway belongs to. The answer will not be a single thunderous revelation, but a careful accumulation of converging lines, the chemical whisper of dates, the geometry of joints, the silence or presence of domestic debris. Yonaguni is a reminder that, beneath the waves, the earth keeps its records in a dialect unfamiliar to the rapid certainties of human storytelling. Listening to that dialect requires humility, equipment, patience, and a readiness to let a beautiful ambiguity persist while the evidence is slowly assembled. What if a single boundary, an invisible threshold between two bodies of water, could transform an inland, productive basin into an abyssal archive almost overnight? What if the sea, in one sudden gesture, could swallow landscapes that had been shaped by human hands for generations, leaving behind a chemical trace and a handful of drowned terraces as its only testimony? This is the thinking that gathers around the Black Sea, a question of thresholds, of breach and rush, and of how quickly whole human worlds can be erased from sight and memory. The Black Sea sits like a bowl at the edge of Europe and Asia, ringed by mountains and fed by rivers that have long carried the continent's sediments to its basin. Today, it reads as a brackish inland sea, with layers of water that barely mingle and a vast anoxic limb at depth that conserves organic matter in a way few other marine basins can. That chemical peculiarities of the Black Sea make it an exceptional preserver. Laminated, oxygen-poor mud that can hold pollen, shells, and other biological whispers in place for millennia. It is precisely these qualities that turn the basin into a tantalizing archive of past environments, and potentially of human displacement. The hypothesis that set the contemporary imagination alight proposed a striking narrative. At some point near the end of the last deglaciation, the land bridge at the Bosporus failed. Mediterranean water, held back by a sill and a delicate balance of sea level and isostatic rebound, poured through. The flood would not have been the slow, polite transgression of a tide, proponents argued. It was a dramatic, hydraulic event, a cascade that remapped shorelines, drowned low-lying river valleys and fertile plains, and left coastal communities scrambling for higher ground. In one formulation, a freshwater lake became a marine sea, its waters salted and its ecology abruptly reordered. In cultural terms, the event was read as the sort of traumatizing landscape shock that breeds myth stories of outrage, divine punishment, or inexplicable loss. It was easy to see why that proposal resonated. It provided a plausible natural kernel that could be woven into the broader fabric of flood tales that recur around the ancient world. Of course, the pleasure of a neat story must be tempered by the slow, messy rigor of data. The Black Sea's sedimentary record is a principal medium for adjudicating the claim. One looks for the classic stratigraphic signature of a transition, freshwater microfossils giving way to marine foraminifera, a sudden change in salinity markers, layers of coarse sand that might indicate violent inundation, palynological shifts showing a conversion of local vegetation, and abrupt changes in carbon isotopes. That could mark a new mode of organic input. In favorable pockets of the basin, places where deposition has been steady and oxygen levels low, those signatures can be preserved with remarkable fidelity. There, a core is a narrow but eloquent timeline, laminated sheets that can be counted, cross-checked, and chemically interrogated. What such cores have shown is both suggestive and stubbornly equivocal. In some cores taken near the ancient shorelines, researchers do find a sharp transition from freshwater diatoms to marine assemblages, accompanied by changes in stable isotopes and sediment grain size. In other places, the transition looks more gradual, the signal smeared over centuries rather than snapped into a single instant. Some cores yield microfossils of marine origin overlain upon freshwater material in a way that suggests a dramatic transgression. Others betray evidence of slower encroachment, episodic pulses of marine ingress separated by intervals of relative calm. The variability is meaningful. The Black Sea is not a single, easily characterized archive, but a complex basin whose record is shaped by local geomorphology, river input, and the vagaries of sediment transport. There is also the problem of time. Radiocarbon dates from organic material in these contexts can be confounded by reservoir effects, differences in apparent age. Because organisms incorporate carbon of different apparent antiquities depending on local water chemistry. Correcting for these effects requires careful calibration, cross-referencing with terrestrial samples when possible, and an awareness of the error bars that will remain. Even when the transition appears abrupt in a particular core, pinning the event to a single calendar year is usually impossible. The evidence more readily supports an interval, sometimes relatively narrow, during which saline water increased and ecosystems reoriented. Beyond the chemistry and microfossils, seismic surveys and bathymetric mapping have painted a more visible picture of a drowned landscape. The continental shelf seaward of the basin contains terraces, submerged paleochannels, and ridges that read like the skeleton of a former coast. These features are the kind by which paleogeographers reconstruct shoreline migration, old river mouths now cut underwater, beach ridges buried beneath marine clays, and sediment fans indicating where rivers once met the air. In places, what looks like a buried estuary is sliced through with layers that record changes in flow and salinity. These geomorphic forms suggest that at least portions of the shelf were once low-lying, habitable landscapes, places with freshwater, soil, and coastal resources attractive to human settlement. That raises the human dimension. Neolithic communities around the Black Sea in the late Holocene were agriculturalists and fisherfolk who depended on the interface between river and sea. The loss of those shorelines would have been a profound disruption, not only to subsistence but to social and ritual geographies. If the basin rose quickly in a given locale, villages would have been forced to move, social networks would have been stressed, and demographic pressure could have migrated inland or along the coast. The archaeology of surrounding uplands sometimes shows increases in settlement density after marsh inundation. Perhaps the trace of pushed populations reorganizing. But the picture is complex. People adapt in many ways, retreating, relocating, changing crops, and the archaeological signature of displacement can be subtle, expressed in shifts of pottery styles, burial practices, or agricultural indicators that are not easily linked to a single dramatic inundation. This complexity underlies the central debate: Was the Black Sea's conversion from freshwater basin to marine sea catastrophic and sudden? Or was it a drawn-out process of transgression and adaptation? The evidence does not offer a single narrative. In some sectors, the switch is abrupt enough to justify the term flood. In others, the sea's encroachment looks incremental. The difference matters. A single mega-flood makes for a potent origin story, one that can easily feed flood myths carried by migrating groups. A gradual transgression produces a more mundane, but historically plausible, set of migrations and cultural shifts. The two models are not mutually exclusive. Different coasts of the basin could have experienced different tempos of change, depending upon local topography, river dynamics, and sedimentation rates. The cultural reverberations are part imagination and part archaeology. Stories of universal deluges, tales of a washed-away world, appear in the literatures and oral traditions of multiple cultures. Their ubiquity suggests a cognitive template. When people experience inexplicable landscape change, narrative grows to contain it. But whether a specific flood tale derives from a particular Black Sea event or from a composite of regional experiences is notoriously difficult to say. Memory transmutes events into myth, time compresses, motives appear, and the natural world is moralized. The sedimentary archive may hold an ecological timestamp, but oral memory translates that timestamp into moral and cosmic meaning. What the Black Sea case also highlights is the ocean's ambivalent duality, its capacity to both obliterate and preserve. Where the basin's depths are anoxic, the sedimentary record is astonishingly conservative. Organic matter survives, pollen is trapped, and microfossils remain legible. Where wave action or river currents are energetic, the signal is mixed or dispersed. This means that the places most likely to reveal human traces are specific: low-energy embayments, buried estuaries, and silt-choked river mouths that shut down bioturbation and lock in seasonal laminations. Those sites act as time capsules. Elsewhere, artifacts are pulverized, scattered, or dissolved. The practical consequence is sobering. Even if entire coastal communities were overwhelmed, their archaeological footprint may persist in only a few spots, easily missed by shallow survey or mistaken for natural deposits. Methodologically, the Black Sea investigation is a model in interdisciplinary constraint. Geophysicists map bathymetry, sedimentologists interpret core stratigraphy, palynologists read pollen spectra, micropaleontologists identify diatom and foraminiferal shifts. Chemists measure isotopes and elemental changes. Geomorphologists reconstruct paleochannels. Each line of inquiry is provisional, and conclusions are strongest where multiple proxies converge. When seismic lines reveal a drowned river channel, and a core from that channel contains a sharp transition from terrestrial organic mud to marine clay, and pollen shifts imply the loss of freshwater wetland plants at the same horizon, then the case for an abrupt environmental change becomes compelling. But even then, assigning agency, whether catastrophic breach or climatic-driven slow rise, requires caution. The Black Sea story thus becomes a meditation on how human experience is nested within geological time. On the timescale of a decade or two, the idea of a flood can be immediate and cataclysmic. On the scale of millennia, it may be one rhythmic pulse among many in a landscape's long life. The basin's record invites a humility. It shows that eco-cultural change can be both accidental and structured, sudden and prolonged, and that the archaeological trace of human suffering is rarely as crisp as the narrative we crave. Finally, the Black Sea offers a contemporary mirror. The dynamics that reshaped its shores, sea level change, coastal erosion, and human adaptation are active today in many parts of the world. Modern populations live within the same physico-chemical constraints that governed ancient shorelines, albeit now with anthropogenic warming accelerating sea level rise. The basin's layered mud, in conserving signs of past change, asks modern listeners to consider not only the fragility of settlements to natural forces, but also the permanence of human marks. In the stratigraphic ledger, if an ancient flood, whether sudden or slow, left its imprint in the basin's chemistry, then the present age too is writing its distinctive ink, altered carbon cycles, synthetic molecules, metals and plastics that will persist in sediments for epochs. In the end, the Black Sea chapter is not a resolved tale, it is an exercise in calibrated wonder. It demonstrates how a sea can be both agent and archive, how thresholds matter, and how the human story is forever entangled with the rhythms of water and sediment. The basin's laminated pages are patient. They await more coring, more mapping, more isotopic scrutiny. Each new sample may clarify one local episode, narrow another uncertainty, and enrich the chorus of data that historians, geologists, and paleoecologists must harmonize. For now, the image persists. A fertile valley turned into a saline bowl. A coastline erased and rewritten in mud, and with it the abiding lesson. The planet's capacity to rearrange its face is as much a feature of Earth history as human resilience and memory are of cultural history. The Black Sea, in its sedimentary quiet, holds both the possibility of a great flood and the more modest truth that, whether sudden or gradual, the sea can make whole chapters of human life recede beneath waves and into the patient custody of mud. What if an object dragged from the dark, an odd ribbon of beaten metal, a shard of pottery glazed with an unfamiliar patina, a precisely hewn block of stone, were to pierce the routine of scientific fieldwork and insist upon a different history? That image, sudden and disorienting, underlies the 7th chapter, the catalogue of strange artifacts lying at the ocean's bottom, the trophies and riddles that surface like blink-to-wake questions about the length and texture of human presence on Earth. The sea yields its oddities in many ways. A trawler's net, sweeping across a shelf, sometimes brings to the surface not merely fish, but things that do not belong to marine life. Shards of fired clay, rusted iron fittings, shapes that do not accord with natural flotsam. Side-scan sonar reveals hard anomalies on an otherwise smooth plane linear shadows, right-angled corners, parallel ridges. Divers and remotely operated vehicles, ROVs, photograph alignments of blocks, anchors, or metal objects scattered across sandy flats. Sediment cores, when split and inspected in the light of a laboratory, sometimes display horizons crowded with micro-remains. Tiny fragments of charcoal, specks of slag, concentrated heavy metals, or biomarkers that suggest combustion and manufacture. The accumulation of these finds creates a modus operandi of inquiry, a slow, patient detective work that translates odd items into hypotheses about occupation, craft, and, occasionally, about deep surprises. There is a first swell of feeling when an object looks unmistakably made. The human eye is wired to read pattern. It recognizes geometry, repetition, edges that suggest tool use. That recognition is accompanied by a more complex affect, a cocktail of awe, giddy possibility, and a sober restraint cultivated by decades of scientific caution. The ocean has a history of producing tempting false positives. Natural processes, Jointed rock, concretion, mineralization can imitate human design. Yet some finds defy easy dismissal. When a corroded mass of iron, under microscopic scrutiny, shows welded seams or a composition of alloys inconsistent with meteoritic nickel iron. When pottery exhibits temper and firing techniques that match no known local tradition, curiosity and professional rigor converge. The temptation to read these anomalies as evidence of lost and old human craft becomes irresistible. Still, the question of age reorients everything. Dating is the fulcrum on which claims of ancient human presence turn. Radiocarbon, the workhorse method for organics, has limits. It reaches reliably back only tens of thousands of years and is vulnerable to marine reservoir effects when shells and marine charcoal are used. Thermoluminescence and optically stimulated luminescence can date the last heating of ceramics or the last sunlight exposure of sediments, but those techniques depend on careful sampling and contextual integrity. Uranium, thorium series dating can time accreted carbonate incrustations on stone or metal, offering windows into submergence histories. For metal itself, age is rarely a direct measurement. Instead, metallurgical analysis, trace elements, and isotopic patterns provides provenance and process information that can suggest technological levels and potential eras of manufacture. Here, the sea complicates. Objects recovered from the seabed are rarely in pristine, in situ condition. Currents can re-roll and rework them. Storms can move heavy items. Biofouling and concretion can obliterate surface textures. Diagenesis, the suite of chemical changes affecting materials buried in sediments, can transform an artifact into something that, to casual inspection, appears ancient in a geological sense, even if it is comparatively recent. A copper object might corrode to a green crust encrusted with calcium carbonate. Its original manufacturing marks hidden. Iron may galvanize into an irregular mass that looks like a natural concretion. The more surprising the original claim, for example, a metallic object associated with a horizon that radiocarbon dates far older than known metallurgy, the more meticulous the provenance and stratigraphic context must be. This demand for rigorous context explains why the truly intriguing claims in marine archaeology are those that come with multiple, converging lines of evidence. A scatter of pottery sherds lying within a coherent stratigraphic layer, capped by a tephra from a known eruption and overlain by marine sediments dated by foraminiferal assemblages, creates a narrative of terrestrial occupation followed by inundation. A linear arrangement of dressed stone blocks within a shallow submerged embayment now characterized by laminated anoxic muds suggests intentional placement and provides a preservation context that allows organic residues or microfossils to survive. In the absence of such convergence, extraordinary dates or odd materials trigger methodological alarms rather than celebrations. There are, however, instances that push the envelope and demand explanation. Metal objects recovered from deep, tightly sealed sediment contexts have on occasion returned startling results, compositions that do not fit local metallurgical traditions, lead isotope ratios that point to distant ore sources, microstructural features, indicating alloying techniques unfamiliar for the geographic and chronological setting implied by associated sediments. Pottery with mineralogies suggesting unexpectedly high firing temperatures, ceramic inclusions that do not match local clays, stone blocks bearing chisel marks that appear idiosyncratic. Each such piece necessitates an interrogation at the intersection of chemistry, stratigraphy, and comparative craft history. The first line of scientific response is always conservative test, retest, and cross-check. Independent laboratories verify isotopic readings, thin section petrography, compares ceramic fabrics, micro-XRF and SEM analyses, probe corrosion layers and microstructures. The possibility of contamination is assessed rigorously had the object been reworked by currents. Might older materials have been recycled into later contexts? Are the dating samples truly associated or merely coincident? It is a juridical process. Each claim of an anomalously ancient artifact must survive the scrutiny of multiple experts across different specialties. The burden of proof is high because the stakes are not merely chronological but epistemological. The older the alleged artifact, the more it threatens established narratives of human technological development. Sometimes the ocean supplies mitigating explanations that align the anomalous with the plausible. Meteoritic iron, for example, confounded early scholars who expected smelted iron only in later eras. Before smelting was widespread, some cultures used meteoritic iron rare hits from the sky as a material for prestigious objects. The composition of a metal object therefore can be a clue to origin that is not necessarily human industrial. Similarly, recycled or repurposed materials can migrate through time. A stone block quarried in one epoch may be reused centuries later in shoreline defenses, and then subsequently buried by marine sediment. The block's presence in an older stratigraphic horizon can be a diagenetic artifact of reworking. But some anomalies remain stubborn, and it is here that speculation widens into philosophic territory. Suppose an alloy of an unfamiliar composition were consistently recovered from multiple sites on the continental shelf. Each occurrence embedded in sediment horizons that, when independently dated, appear to predate known metallurgical traditions by tens of thousands of years. What then? The methodological answer is uncompromising. Replicate sampling, expand spatial coverage, seek independent proxies such as trace element signatures in surrounding sediments, evidence of nearby pyrotechnology, charcoal layers, soot, slag, and biological indicators such as domesticate DNA. The conceptual response is humbler. Entertain the range of possible mechanisms, natural geochemical formation, meteoritic bodies, human manufacture, or even sampling artifacts, while acknowledging the desire all humans have to find continuity between present craft and deep past. That desire is itself a subject of reflection. The cultural hunger to uncover deep human accomplishment animates public fascination whenever a trawler brings up a metal object. With an unfamiliar alloy, it fuels headlines and raises expectations. This appetite must be balanced by the slower rhythms of scientific labor, a labor that often yields a cheerless parade of negative results. Radiocarbon reversals, reservoir corrections, indications that an object was redeposited in a younger layer. Yet those negative results are productive. They teach about the processes of preservation and the frequency of false signals in marine archives. They refine methodology, forcing investigators to hone sampling protocols, record chain of custody with legalistic care, and develop blind testing frameworks that insulate data from wishful interpretation. There is also a distinct literary and existential thrill when artifacts seem to challenge the temporal horizon of recorded history. The idea that objects lying under centimeters of silt might date to periods far older than extant written records is intoxicating, because it enlarges human time. It is a reminder that human cultures leave traces beyond texts and monuments, that forgotten economies and technologies could have existed in places where preservation is poor and observation scarce. but it is essential to separate the emotive pleasure of possibility from the epistemic requirement of evidence. Extraordinary claims demand extraordinary convergence of proof, stratigraphy, independent dating, multiple proxies, and material analyses that can withstand interdisciplinary scrutiny. Technologically, the tools to adjudicate such claims have become more powerful and more accessible. Multi-beam sonar provides maps of seafloor morphology that allow precise targeting of anomalies. Sub-bottom profilers reveal buried structures beneath meters of sediment. High-resolution cores extract intact laminae that can be read like thin books. ROVs and human-occupied submersibles permit direct visual inspection and microsampling. In the laboratory, developments in mass spectrometry, isotope geochemistry, and ancient DNA analysis add nuance to interpretation. Lead isotope provenance links copper and bronze to specific ore regions. Sulfur isotopes and elemental ratios speak to metallurgical practices. Sedimentary ancient DNA can, under ideal conditions, tell whether domesticated barley or wheat were present in a given horizon, an indirect but potent signal of agricultural activity. When such methods are combined, the marine archive can be interrogated with an economy of cross-confirmation that was unthinkable a generation ago. Yet the ocean's chemistry also produces illusions. Concretion can encapsulate later artifacts in what appears to be a continuous mineral mass, making secondary accretions look like primary manufacture. Bacterial mats and mineral precipitation can mimic tool marks. Orthogenic mineral growths, minerals that form in place within sediments, can create pseudo-artifacts, symmetric shapes born of chemistry rather than intention. Disentangling these from true manufacture requires a forensic attention to micro-scale features, tool striations, microabrasion patterns, microfossil inclusions that betray either a human hand or a chemical genesis. The public dimension cannot be ignored. Reports of anomalous metal objects older than recorded history circulate widely, often divorced from the cautionary uncertainties that characterize scientific reporting. Social media accelerates myth-making. Fringe narratives seize upon anomalies to support grander claims about lost industrial ages or erased civilizations. Scientists, therefore, find themselves not just as analysts, but as stewards of method and narrative. There is an ethical imperative to communicate both the wonder of the finds and the limits of the evidence, to educate audiences about how layers of mud and chemistry, not headlines, compose the long tail of human presence. All of this loops back to a larger, melancholic reflection on temporality. Objects on the ocean floor are not merely curiosities, they are the stratigraphic punctuation marks of human activity. Their distribution, composition, and age encode stories about trade networks, craft traditions, the movement of peoples, and the abruptness or gradualness of environmental change. Where artifacts appear in horizons that predate known technologies, they force humanity to reconsider narratives of technological emergence and diffusion. But any such reconsideration must rest on robust, multi-proxy evidence. The ocean does not surrender its secrets easily, and the longer the temporal distance, the more carefully inference must be constrained. Finally, there is a consoling and unsettling moral. The sea preserves, and it forgets with equal fidelity. It can lock a wooden plank into anoxic mud for millennia and dissolve a stone wall into indistinguishable rubble in a single storm cycle. It can preserve chemical signatures of combustion in laminated sediment and at the same time recycle metals into indistinct oxides. The artifacts that survive are not an unbiased sample of past human life, they are the contingent results of materials, chemistry, context, and chance. To interpret them properly is to accept the partiality of the archive and to celebrate the fragility that each recovered object reveals. A shard or a metal fist is both a testimony and a question. A fragment of a life once lived and an index of the immense temporal apparatus that decides what endures. In the end, the catalogue of strange artifacts on the seafloor is less an inventory of lost wonders than an invitation to patient, multidisciplinary listening. The modern toolkits, sonar maps, sediment cores, isotopic analysis, ancient DNA permits, reading of pages once sealed by water. Yet reading demands humility. Extraordinary ages attached to metal or ceramic finds require the slow choreography of corroboration. Match stratigraphy, independent labs, contextual proxies. The sea's deep archive will not be pried open by wish alone, it yields to method. And in that yielding it reshapes human stories about antiquity and continuity. Each enigmatic object that emerges from mud is not simply a relic, but an interlocutor. It asks not only what humans might once have been, but how those humans are remembered or effaced by the slow, indifferent, and occasionally generous work of the planet. What if the sea had been more than a highway and a pantry for earlier peoples? What if it had been a machine? That simple inversion is the question that opens this chapter. Imagine ancient engineers not only sailing and fishing, but deliberately planting structures, channels and devices to make the water itself do work. It is a provocative proposition because it rearranges a familiar chronology of technological progress. The notion insists that the ocean could have been, and perhaps was, an energy source in deep time harnessed, shaped, and integrated into human economies in ways that leave only faint fingerprints beneath waves. There is a practical logic to the idea. Water, in its motions and gradients, is one of the planet's most reliably recurring flows. Tides are cosmic clocks, regular and calculable. Waves are continuous transferences of wind energy over long distances, coastal. Currents concentrate kinetic power into narrow straits. Thermal gradients between surface and depth store potentials that run for seasons, if not centuries, to societies living at the margin between land and sea. These consistencies would have looked like opportunities rather than abstractions. Where wood, peat, or animal labor were constrained by resource limits, the sea offered a continuous, renewable source of force if people could learn to intercept it. Speculative reconstructions of how that interception might have been achieved fall into categories that are both ancient and modern in feel. Some possibilities are extensions of well-documented, historically attested technologies. Tidal mills and weirs, for instance, exploit the ebb and flow of tides to generate repeated, predictable lifting and dropping of water. Simple hydraulic batteries, in effect. Medieval and later societies dammed estuaries and channeled tidewaters through mill races. The same principle, scaled and adapted, could have been applied in older times wherever tidal ranges were sufficient and stone foundations were feasible. A network of sluices, stone-lined basins, and weighted gates could store potential energy on each flood and release it to turn mechanisms on the ebb grinding grain. Pumping water or powering workshops. Other concepts reach further into the domain of engineering imagination. Wave-attuned structures, rows of submerged terraces or breakwaters arrayed at particular angles could have acted as primitive oscillators, capturing wave energy and converting it to usable motion. Oscillating water columns, known to modern engineers as efficient wave energy devices, might find an analogue in natural sea caves or man-modified inlets. A trapped pocket of air compressed and rarefied by incoming swell produces force that can turn a turbine-like mechanism. A coastline sculpted into a series of chambers and conduits would have the capacity to rectify wave motion into directed mechanical work. Straits and channels concentrate flow, making them natural loci for harnessing current energy. A series of posts or stone piers placed across a narrow throat could funnel water through apertures, accelerating it and creating sites where water wheels or turbine analogues, perhaps of wood and rope rather than iron and steel, could have been attached. Even the simple technology of paddle-driven wheels, when mounted horizontally in a fast-moving tidal stream, generates torque. Multiply that arrangement across a shoreline, and the cumulative work could be substantial. The thermal profile of the ocean offers another speculative arena. Ocean thermal energy conversion, OTEC, exploits small temperature differentials between warm surface layers and cold deep waters to run heat engines. In principle, a pre-industrial analogue could be imagined not as a high-efficiency plant, but as an exploitation of hot springs or localized hydrothermal upwellings where temperature contrasts were sharper. Warm vent water, channeled through masonry and mixed with colder currents, could drive pressure differentials and provide motive force or chemical gradients for early industry. Similarly, gradients in salinity, where rivers met the sea, create osmotic potentials. Harnessing such differences intentionally is technically demanding, but coastal people did already manipulate brackish zones for aquaculture and salt making, practices that could have had energetic byproducts or been part of complex systems. Chemical energy should not be overlooked. Methane seeps, biological mats, and extensive kelp beds concentrate organic energy at the sea-land interface. Large-scale aquaculture, deliberate mariculture of shellfish, seaweeds and fish constitutes a way of stocking and extracting biological energy that, given rudimentary processing technologies, could support craft specializations and densify labor. The residue signatures of such practices are not always easy to separate from ordinary foraging, but they are energetic behaviors nonetheless. The cultivation, harvesting and processing of marine biomass is a transfer of ecological work into human economic work. If any of these strategies were practiced at scale in antiquity, the archaeological record would be, predictably, ambiguous. Water-based energy systems are materially promiscuous. They employ wood, organic seals, rope, and jointed timbers at their core. Materials. The sea readily consumes unless rapidly sealed in anoxic sediments. Yet there are durable hallmarks that might survive. Stone foundations for sluices, aligned piers and piles preserved as mineralized hollows, rock-cut channels and terraces, heavy mortar-filled sockets for mounting axles. These are features that resist dissolution. Where stoneworks were built in places later submerged and then quickly buried by silt in low-energy basins, the chances of survival increase. The same anoxic conditions praised earlier for conserving pollen and DNA can preserve wooden elements and organic fastenings for millennia if the burial is rapid and oxygen is excluded. What would researchers look for? The field makes modest, testable predictions. First, engineering logic implies orientation. Structures meant to harness tidal or current energy are likely aligned with prevailing flow vectors. Linear arrays of blocks or channels oriented obliquely to the shoreline, not parallel beach defenses, but apertures oriented into the current would be a telltale alignment. Second, wear patterns at nodal points. Stone sockets exhibiting asymmetrical polishing or scour indicative of repetitive. Rotational motion would suggest the presence of axles or wheels. Third, Concentrations of heavy metals and combustion residues in sediments proximal to such structures might indicate industrial processing powered by mechanical energy, smithing, ceramic kilns, salt evaporation enhanced by mechanically driven pumps, or large-scale food processing. Fourth, biomolecular traces. Abundant signatures of domesticated algae or shellfish in cedar DNA, or abrupt shifts in nitrogen isotopes signaling changes in diet and marine resource exploitation, could reveal intensified, organized uses of sea products consistent with mariculture supported by mechanical infrastructures. These predictions are already within the reach of contemporary methods. Multi-beam bathymetry and sub-bottom profiling can reveal channels, terraces, and hollows with striking detail. Magnetometry and acoustic imaging highlight linear anomalies and buried walls. High-resolution coring in depositional pockets can recover laminated sequences containing soot peaks, metallurgical slag, or orthogenic mineral crusts that form where heated effluents met seawater. Ancient DNA recovered from marine sediments can identify compositional shifts in local ecosystems, domesticated strains of seaweed, for example, or the proliferation of species associated with human-managed habitats. Trace. Element geochemistry and lead isotope provenance studies can tie concentrations of bronze or copper residues to specific supply zones, hinting at the existence of connected industrial networks. Yet caution is not merely methodological, it is epistemic. The sea is a cunning revealer. It both preserves and disguises. A stone alignment that appears purposeful may be an expression of jointing and bedding. A regular array of pits might be. Biological burrows or erosional features, metallurgical residues can be introduced by later wrecks or localized geological processes. Thus, any claim that structures were parts of energy systems must be built on converging evidence. The strongest cases will combine geomorphology, microstratigraphy, material culture, and chemical anthropology, the same multi-proxy approach already advocated for submerged habitation studies. If traces of ancient marine energy systems do exist, their discovery would be more than a curiosity. It would reorient how one thinks about social complexity in coastal zones. Energy shapes social organization. A community that can tap continuous mechanical power, however simple, the technology can marshal greater labor, run heavier industries, and build different material cultures than one constrained to sporadic manual power. The presence of energy infrastructures at scales beyond household needs implies coordination, investment in public works, perhaps institutions for maintenance and knowledge transmission. Conversely, the absence of such visible infrastructures need not be read as absence of energy use. It might simply indicate the fragility of the materials employed. The speculative element of this inquiry also touches on myth and memory. Stories of harnessing the sea, of sacred walls and channels that controlled floods, or of legendary works, structures that command the tide, are widespread in coastal cosmologies. Whether these stories encode memories of real hydraulic engineering, symbolic expressions of control over nature, or a mixture of both is an open anthropological question. Yet the persistence of such narratives suggests cultures long experienced the sea not only as threat and food, but as a power to be negotiated, modulated, and, sometimes, exploited. There is a moral dimension as well. In contemplating ancient marine energy, modern listeners confront an uncomfortable mirror. Contemporary societies are energetically voracious. and large-scale marine energy extraction is now a reality, from tidal turbines to large wave farms. Imagining a deep past in which coastal populations harnessed analogous forces invites reflection on sustainability, scale, and the durability of infrastructural imprints. If ancient systems, modest by today's standards, left subtle geological and chemical marks, what will the enormous marine projects of the Anthropocene leave in the sedimentary ledger? The question returns, narrative-focused to stewardship. Energy use always writes itself into the earth, sometimes in ways only visible to deep-time readers. Operationally, the path forward is straightforward in outline, difficult in practice. It requires targeted surveys of paleotidal inlets, submerged deltas, and straits where flow energy is concentrated. It requires focused coring in low-energy basins adjacent to candidate structures. It demands integrated hydrodynamic modeling to test whether observed formations could realistically have delivered usable power. And it depends on careful geochemical assays that can detect anthropogenic signatures in marine sediments. Experimental archaeology, reconstructing plausible devices and testing their effectiveness under modeled conditions, can complement remote sensing and lab work, providing a sanity check on whether the sea's physics afford the exploitation envisioned. Even if the record is thin, and it probably will be in many locales, the intellectual value of the inquiry is significant. Hypothesizing ancient marine energy systems reframes what counts as early technology. It expands the set of landscapes archaeologists interrogate, and it emphasizes that energy regimes, who controlled them and how, are central to long-term human history. More poetically, it restores to the sea a role once central to human life but rarely highlighted in deep-time narratives, that of collaborator. The ocean has always been a giver and taker. To imagine it also as a worker in human economies is to enrich the possible. Biographies of early societies. Finally, this chapter reiterates a theme threaded through the previous parts. The ocean's archive is partial, ambiguous, and often mute. It holds potential answers, but it demands patience, humility, and methodological breadth. The search for ancient marine energy systems will not be satisfied by a single sensational find or a tidy headline. It will require decades of careful mapping, coring, and skeptical interpretation, an interdisciplinary choreography in which geophysicists, sedimentologists, chemists, paleoecologists, and archaeologists translate the sea's layered silences into narrative. If the hypothesis proves empty, that absence will itself be informative, a data point about how societies adapted without harnessing the sea's kinetic or thermal wealth. If evidence is found, the discovery will expand the conceivable scope of human technological creativity. Either outcome sharpens the larger lesson of this inquiry. The ocean is not merely a backdrop to human history. It is a reservoir of potential activity and a record of past decisions. To test whether ancient peoples deliberately made the sea do work is to test the limits of archaeological imagination and to acknowledge that our current understanding of technological trajectories may be narrower than reality. Above all, the question encourages a different posture toward the past, one that listens for machinery in the laminae of mud. That reads orientation and abrasion as signs, and that recognizes how much ingenuity can be erased by time, yet hinted at by the stones and chemistry left in its wake. What if the largest library of Earth's memory has been locked, not in stone or parchment, but beneath a pressure so great that light never reaches it? The thought insists on itself with a simple, almost brutal statistic. more than 80% of the ocean remains effectively unexplored. That number is not merely an inventory of gaps, it is a statement about silence. It means that, for the majority of the planet's surface, the pages of its history have not been opened, their ink not yet read. It means the world still shelters whole chapters, ecologies, chemical shifts, and perhaps human stories that have never been examined with methods capable of translating deep time language into modern sense. This silence has shape. It is the blackness of the abyssal plain, a vast, flattish expanse of mud and silt where sediments fall in a slow snow from the productive surface waters above. It is the vertical corridor of the Haddle Trenches, places so deep that the curvature of light is irrelevant and pressure folds rock into unfamiliar geometries. It is the rugged topography of seamounts and undersea volcanoes, ribbed ridges that have never been trawled, where vents exhale, chemical-laden plumes and whole communities hinge on chemistry rather than sunlight. It is the interior of continental margins beyond the reach of shallow surveys. A labyrinth of drowned river mouths and buried deltas that might hold, in their layered filling, the traces of ancient shorelines and the livelihoods once anchored to them. To say so much remains unexplored is to admit a profound asymmetry in knowledge. Satellite altimetry and global bathymetric compilations sketch the ocean's face at broad scale, but the resolution is crude. The majority of high-resolution multi-beam maps, those capable of showing details at the scale at which archaeologists and sedimentologists read human and environmental action cluster near coasts and around a handful of scientific expeditions. The sea floor that lies beneath the open ocean, under the long sweep of the trade winds and the sluggish gyres, has been sampled with the same neglect that a reader might give to the spine of an unloved book. Where human curiosity has been most intense, on continental shelves and in bays, preservation conditions occasionally yield readable fragments. The drowned plains of Doggerland, the laminated anoxic stacks of the Black Sea, the submerged masonry off Gujarat. But beyond those well-mapped margins, the ocean keeps its own counsel. That counsel is both biological and chemical. The deep seabed is not merely empty, it is a complex living system with its own dynamics and its own modes of preservation. In anoxic basins, the slow, patient accumulation of mud can lock away organic molecules, pollen, and DNA. In huddled trenches, the flux of particulate organic carbon can sustain a deep biosphere of microbes living in sediments and igneous rock. Around hydrothermal vents and cold seeps, mineral precipitation preserves forms, chimneys of sulfide and carbonate that accrete with the signatures of microbially mediated processes. Even manganese nodules, those metallic concretions that dot abyssal plains, are time capsules of chemical conditions, accreting over millions of years and embedding within them isotopic and elemental signals of ocean chemistry. The archive is not uniform, it is a geography of opportunity, and much of that geography lies unvisited. The practical reasons for this neglect are not romantic. Deep ocean exploration is expensive, technically demanding, and slow. Platforms must be built to withstand corrosive salt and crushing pressure. Instruments, autonomous underwater vehicles, remotely operated vehicles, coring rigs, must be deployed with surgical care. Each sediment core returns only a narrow pencil of time through an expanse the size of nations. The International Ocean Discovery Program, the fleet of research vessels and coring platforms that have so patiently peeled thin vertical slices from the seafloor, has shown how rewarding this labor can be. Continuous records of climate swings, sudden events, and biological turnover. But each core is a point sample in a near-infinite landscape. To map, sample, and interpret the parts of the ocean where signals are likely preserved requires both financial commitment and a collective will that is often lacking. That lacuna matters because the deep ocean has been, and continues to be, a recorder of planetary shocks, some gentle and incremental, others abrupt and world-changing. Its strata contain the chemical signatures of massive volcanic outpourings, of methane releases, of oceanic anoxic events that suffocated life at continental scales. When the planet has tipped into a different mode, when carbon poured into the atmosphere and oceans within a geologic blink, the sea has often been the place where that tipping was most faithfully recorded. For instance, the Paleocene-Eocene thermal maximum, the so-called PETM, shows in deep-sea cores a marked excursion in carbon isotopes and an associated wave of extinction and turnover among benthic foraminifera. The same layers tell of acidification and a recalibration of marine carbonate chemistry. These are not abstract phenomena, they are precedents, archived in mud, of how the coupled atmosphere-ocean system responds when greenhouse gases surge rapidly. That archive, when read carefully, functions as warning as much as record. The sea remembers episodes when greenhouse gas inputs rose and the consequences cascaded: warming, reduced oxygen in the deep ocean, shifts in biogeography, and mass mortality among organisms that could not adapt fast enough. It preserves the chemistry of those years, changes in sulfur and carbon isotopes, peaks in certain trace metals that correlate with volcanic ash, layers rich in organic carbon indicating widespread anoxia. Today's anthropogenic emissions, while different in cause, animate comparable pathways. The deep-sea pages that describe past surges of carbon are thus also cautionary manuals. They spell out the mechanistic sequences that can lead from perturbation to ecological reconfiguration. There are also more localized, humanly legible warnings entombed beneath the waves. The modern industrial imprint is surprisingly durable. The mid-20th century, the dawn of nuclear tests, the acceleration of fossil fuel combustion, the spread of synthetic chemicals already leaves a sharp stratigraphic horizon. Radionuclide peaks, particularly in the 1950s and 1960s, are detectable in both ice cores and marine sediments. Lead isotopes reflect the global exchange of metal and the isotopic fingerprint of leaded gasoline. Plastics, microplastics, and persistent organic pollutants have become part of the sedimentary fabric. In the same way that a poet finds meaning in an index, a paleoceanographer sees in these horizons a message. Human activity writes itself into deep time. That imprint is not just proof of presence, it is warning. If the modern fingerprint is profound and planet-wide in only a few decades, what will centuries of continued disturbance do to the ocean's chemistry and to the record it contains? The deep sea also hides the consequence of accelerated change in forms that are less headline-friendly. Warming waters reduce oxygen solubility and can reconfigure the distribution of oxygen minimum zones. Chemical stratification of the ocean, changes in temperature and salinity that affect circulation, can stall the mixing that brings oxygen to the bottom, creating larger anoxic regions where organic matter accumulates but fauna decline. Acidification, the dissolution of calcium carbonate, dissolves the shells of planktonic organisms that are central to the marine carbon pump. In many cases, these are threshold behaviors. Small changes can produce nonlinear responses. The deep ocean is not immune to such dynamics. It is part of the planetary engine. It stores heat and carbon. When its processes change, the results ripple back into climate and into human food systems. There is another, more painful warning embedded in the ocean's silence. Something can vanish before it is ever seen. The global appetite for seabed resources, manganese nodules, polymetallic sulfides near hydrothermal vents, cobalt-rich crusts on seamounts, has shifted from niche interest to active prospecting. The technologies that would uproot those resources are becoming economically feasible. Deep-sea trawling, already a scourge for shallow shelf ecosystems, has proven capable of obliterating slow-growing benthic communities. Mining operations promise to churn sediment columns and scatter plumes for hundreds of kilometers. The problem is not merely ecological loss, it is epistemic. Disturbing an anoxic lamina that has held DNA, pollen, and chemical indicators for tens of thousands of years would be to tear pages from the planet's book without reading them. Once mixed, those layers cannot be unshuffled. The evidence encoded in their delicate micro-layers, the story of how an estuary responded to a flood or how a coastline migrated. Over centuries would be lost, and with it the chance to learn from past episodes of environmental upheaval. This is a political as well as scientific dilemma. The sea beyond national jurisdiction is, by treaty, the Commons. The International Seabed Authority exists to govern mineral exploitation in the deep sea. But governance lags behind commercial interest and technological capacity. Conservation initiatives and calls for precautionary measures argue for moratoria on mining until a more thorough scientific baseline is established. That plea is not merely conservationist rhetoric, it is an epistemic imperative. The place between discovery and exploitation must be held as a pause in which humanity can learn what is there and what will be. Lost, not to indulge nostalgia, but to ensure that decisions are informed by an understanding of ecological and historical value. There is also an ethical axis. Looking to the deep sea as a repository of both wonder and warning calls for a humility about human ambitions. The planetary ledger is not only a ledger of goods extracted, it is a slow ledger of processes, chemical cycles, biological adaptations, and the cumulative record of human intrusion. Imagining the deep ocean as a fragile archive reframes stewardship as stewardship of knowledge as much as of species. It suggests that the modern era's rush to commodify the seafloor must be tempered by the recognition that some damage is irreversible, not only ecologically but narratively. Destroying an archive is not only to kill life, it is to erase possibilities for future understanding. The opportunities are, nonetheless, immense. New technologies, autonomous vehicles that can map the abyssal plains at high resolution, submersibles capable of reaching Hadal depths, improved coring rigs that can extract undisturbed laminated sequences are changing the odds. International programs aiming to map the entire seafloor at high resolution by mid-century, coupled with targeted coring campaigns in paleo-shoreline zones and anoxic basins, can turn the silence into readable pages. Interdisciplinary teams, geophysicists, geochemists, paleoecologists, sedimentary ancient DNA specialists, and careful statisticians can stitch multiple proxies into coherent narratives. The agenda is not merely academic curiosity, it is a practical program of planetary risk assessment. To understand how the Earth system responded to large perturbations in the past, so that the consequences of current perturbations can be anticipated. There is, finally, a human feeling woven into this, the feeling of smallness and of provisional tenure. The ocean's depth is a humbling measure. In the ledger of geological time, human civilizations are often footnotes. The archives that lie in the deep seabed outlast empires and mythic cities alike. But that endurance is fragile in its particularity. It depends on chemistry, on burial, on anoxic isolation, on the absence of later disturbance. The realization reframes ambition. It is not merely that civilizations can be erased, it is that their traces, if not captured, will be gone forever. The deep sea is both repository and admonition, the planet's long-term memory and the quiet voice that warns what will remain of us. If the previous chapters have wandered across drowned plains and terraces through vented chemistry and the politics of stone, the current vision tightens into an imperative. The unexplored majority of the ocean is not an exotic other. It is a theatre in which the mechanics of climate, life, and human action interplay at scales both vast and intimate. Its unmapped reaches are not neutral voids, but potential libraries of human and planetary history. To leave them unrecorded, and then to mutilate them for short-term gain, is to act as an amnesiac steward, confident that forgetting is costless. The sedimentary warnings from the past, those chemical signatures of rapid carbon release, anoxia, and ecological upheaval, remind humanity that patience and observation is a form of prudence. Mapping, sampling, and protecting the deep ocean are not distractions from progress, they are obligations. The planet writes its lessons slowly, the act of listening, of assembling the quiet data into a coherent counsel, may be the most urgent technology the species has left to develop. What does it mean to read a vanished world when the library is made of mud and the ink is chemical? That question sits at the heart of the contemporary effort to search the sea floor. Modern oceanic archaeology is not a romantic hunt for lost palaces so much as a painstaking program of detection. An orchestration of vessels, sensors, corers, and laboratories designed to coax faint, often ambiguous signals out of layers that have slept for millennia. The work is technical, slow, and impossibly exacting. It is also shot through with the same human yearning that has always driven exploration, the desire to know where people lived, how they worked, and what they left behind when the shoreline moved. The earthquake struck, or the sea surged in. In the last 3 decades, an infrastructure for that search has taken shape. Oceanographic institutions and programs, some long-standing, some newly funded, have turned their instruments toward continental shelves, drowned river mouths, and anoxic basins in a way that would have been inconceivable a generation earlier. The International Ocean Discovery Program, IODP, and its predecessors have drilled long, continuous cores from deep basins and shelf margins, producing vertical time columns that can be read with an arsenal of proxies, microfossils, isotopes, biomarkers, and ancient DNA. Ship platforms owned by research centers and philanthropic initiatives. Vessels like the multidisciplinary platforms of the Schmidt Ocean Institute or the exploration-focused cruises of the Ocean Exploration Trust now carry multi-beam sonar, sub-bottom profilers, and remotely operated vehicles, ROVs, that can map seafloor architecture in exquisite resolution and then inspect targets at human eye scale. The methods are the story as much as the institutions. Multi-beam sonar expands the seafloor into a 3-dimensional surface, revealing terraces, channels, and irregularities that might otherwise pass as anonymous mud. Side-scan sonar paints shadows that call attention to hard objects lying on a flat. Sub-bottom profilers look beneath the first meters of sediment and reveal buried layers, paleochannels, tephra beds, abrupt pulses of coarse material that could be the sedimentary signatures of storms or tsunamis. Autonomous underwater vehicles, AUVs, cruise pre-programmed grids, gathering dense bathymetric data. ROVs descend on fiber optic tethers, their lights carving the dark into brief theatres where cameras record every geometry and manipulator arms can collect a shard or chip a sample. When the coring rig is lowered and the piston corer returns upward, it brings with it a long, narrow cylinder, a rolled history. The lab slices it, photographs it, subject it to X-ray, to thin section microscopy, to mass spectrometry, and to ambient DNA extraction. The core is not a treasure chest. It is a thin book whose sentences must be translated by many hands. The projects that have focused on specific questions illustrate both the power and the limits of these techniques. Studies of the Black Sea Basin combined seismic imaging, coring from research drills, and paleontological analysis to argue for an interval, whether gradual or punctuated, in which salinity rose and landscapes were buried. Doggerland research in the North Sea brought together cores taken from seafloor fans, paleo-channel mapping, and the accidental recovery of Mesolithic artifacts by fishermen to reconstruct a drowned plain that once linked Britain to continental Europe. Off the coast of Gujarat, surveys paired side-scan sonar and diver investigations with sediment cores to produce a patchwork of evidence for human work at or near former shorelines. In each case, the most persuasive reconstructions are not built on single, dramatic finds, but on the convergence of geomorphology, microfossil assemblages, radiometric dates, and material culture recovered in context. There is an effective cadence to these operations. Teams that have stood over a freshly split core describe a mixture of anticipation and calculated restraint. A thin, dark lamination rich in charcoal or soot can set off an electrophoresis of possibilities. Is this evidence for burning and therefore human presence, or is it a signal of natural wildfire transported into the basin? A spike in heavy metals raises questions about metallurgy or long-range volcanic input. A sudden appearance of domesticated plant DNA in an otherwise wild pollen record invites the hypothesis of cultivation or trade. The emotional reflex is to narrate, to fill gaps with story. But the scientific reflex is to slow down, to test for contamination, to seek replication, and to compare laboratories. That tension between human eagerness and methodological conservatism defines the temperament of the field. Two features shape priorities. First is preservation potential. Not all coastal places leave legible traces. The most promising archives are low-energy embayments, drowned peatlands, and stratified basins where oxygen is low and laminae can be preserved without bioturbation. In such settings, organic materials, DNA, and seasonal signals can survive. In energetic open-shelf environments, evidence is likely to be scoured and dispersed. That is why research teams prioritize deltas, estuaries, and restricted basins when searching for archaeological proxies. Second is a heuristic for site selection. Paleotopography matters. Bathymetric terraces that align with reconstructed sea level curves, submerged river mouths traced by seismic lines, and buried beach ridges detected by sub-bottom profiles all act as signposts pointing to locations where human occupation was once plausible. The pairing of remote sensing and targeted coring is therefore the basic ritual. Map widely, then sample deeply. At the same time, the projects confront a suite of stubborn technical obstacles. Dating is a perennial problem. Radiocarbon in marine contexts requires reservoir corrections. Organics can be reworked. Shells may contain old carbon. Encrusted organisms incorporate carbonate over long periods. Interpretation of sedimentary signals is probabilistic, not deterministic. Distinguishing a tsunami deposit from a storm surge can be difficult because both can deposit coarse material landward of the beach. A tephra layer is a precise chronostratigraphic marker when it can be geochemically fingerprinted to a known eruption. But its absence is not proof of absence. Ancient DNA from sediments offers extraordinary potential, revealing the presence of domesticated plants or animals in the absence of artifacts. But it is exquisitely sensitive to contamination and to diagenetic degradation. The signal often lies on the knife edge between detection and noise. Beyond methods, the work has become entangled with contested meanings. Submerged discoveries can be recomposed into national narratives, spiritual claims, and political agendas. The discovery of stone alignments or anchors near a culturally significant site can ignite public debates. Religious communities may read confirmation of sacred histories. Governments may see heritage that bolsters national identity. And scientists plead for patient, transparent analysis. The result is that oceanic archaeology is seldom a purely academic enterprise. It is embedded in broader conversations about stewardship, ownership, and memory. International bodies, UNESCO among them, have sought frameworks for protecting underwater. Cultural heritage and legal regimes increasingly recognize that what lies offshore is not the open hinterland of resource extraction, but the repository of collective pasts. That recognition collides with new pressures. Technological advances in deep-sea mining and resource extraction raise the likelihood that productive surveys may be overtaken by commercial interest. Mining exploration plumes risk obliterating laminated sediments that preserve paleo-environmental histories. Trawling destroys slow-growing benthic ecosystems and can scatter artifacts irretrievably. The International Seabed Authority's deliberations about mining governance in international waters are not merely about minerals. They are about whether the planet's slow histories will be sacrificed for short-term gain. Scientists have begun to frame the deep ocean not only as an ecological frontier, but as a fragile library. Once pages are ripped, they cannot be resealed. Can contemporary humanity learn from these projects to avoid repeating the calamities that sometimes erased human worlds in the past? The answer is both conditional and urgent. The empirical promise of marine archaeology is to expand the sample of past episodes, how coastlines responded to rapid sea level change, to tsunamis, to storm clusters, to abrupt salinization, and to refine models of human response. That knowledge is actionable. Paleo shorelines reveal where people once were vulnerable. Sedimentary records quantify the rapidity of change in local contexts. Tephra layers and tsunami deposits allow hazard calibration. In principle, these insights feed into modern coastal planning: where to prioritize retreat, where to fortify, what damages to expect under particular rates of rise or storm intensity. The sea's past is therefore a laboratory for resilience. But the translation from knowledge to prevention is not automatic. Societies that failed in the past did not always do so because they lacked information alone. Political will, social inequality, resource constraints, and competing temporal horizons shape whether communities adapt. The submerged archives that show rapid inundation remind modern planners that the speed of environmental change can outpace institutions and technologies. And climate change today is not merely an isolated geophysical process to be studied in cores. It is a socio-technical challenge that demands emissions, reductions, economic transformations, and redistributive policies. The sediments can advise, but they cannot make policy. There is also a moral and procedural urgency in protecting the archives themselves. If the goal is to learn from the past in order to avoid future catastrophe, the first step is to preserve the information repositories that allow inference. That means expanding high-resolution mapping of continental shelves, increasing coring campaigns in anoxic basins and paleodeltas, and imposing precautionary restrictions on seabed disturbance until baseline science is substantially improved. It also means building open data infrastructures so that sonar grids, core logs, and geochemical assays are available to an interdisciplinary community. The alternative is to degrade the preconditions for knowledge while still hoping that policy will be evidence-based. Successful pathways already exist in miniature. Collaborative projects that couple scientific surveys with local stakeholders, coastal communities, fisheries, indigenous groups produce not just data but trust. Workshops that translate paleoclimatic records into municipal planning scenarios have helped some coastal municipalities rethink infrastructure and zoning. Early warning systems for tsunami risk, informed by geological mapping of past events, have protected lives. Yet these successes are mosaics rather than a general rule. The bottleneck is often institutional, funding cycles that privilege short-term, high-profile interventions over long-term coring programs, governance frameworks that prioritize resource extraction over heritage, and a public imagination inclined toward dramatic excavation narratives rather than slow sedimentary carefulness. The Sea's archive, when read well, does something else. It reorients human humility. The layered mud and chemical spikes do not just record disaster, they record resilience, adaptation, and continuity. Some communities responded to shoreward loss by relocating successfully, some shifted subsistence strategies, others forged new social networks. These outcomes are not assurements, they are variables. The archaeological lesson is not a single moral, but a conditional ethic. The best chance of avoiding catastrophe is to combine good knowledge gleaned from the seafloor with governance that is anticipatory, equitable, and willing to make sacrifices now to avoid greater loss later. The ongoing oceanic archaeological projects therefore play two roles at once. They are forensic. They seek to reconstruct past events so that models of risk are empirically grounded. They are also civic. They produce narratives that can inform public debate about what is worth protecting and how to live with a changing sea. That duality is why investment in these programs matters. It is not simply nostalgia for lost cities. It is pragmatic risk assessment folded into a deeper conversation about human finitude. There is an irony in the timing. Just as the toolbox for reading the seafloor becomes more powerful, sequencing ancient DNA from sediments, imaging buried channels with unprecedented resolution, modeling hydrodynamic consequences of hypothetical tsunamis, the window for preserving many archives narrows. Rising seas are already remaking shorelines. Extraction technologies are poised to disturb previously untouched records, and political attention is often diverted to immediate crises. The risk is that the discipline will be rendered retrospective by losses that could have been documented if only the work had been prioritized earlier. So the question of whether humanity will avoid repeating the tragedies of the past does not resolve into a single sentence. The oceanic archaeological community can and does provide maps of vulnerability, calibrated models of past extremes, and empirical baselines for hazard assessment. These are necessary ingredients for adaptation, but they are not sufficient. Will requires institution building, redistribution of resources, and collective decisions that align short-term interests with long-term survivability. The seas will record what happens either way. They keep their pages of consequence with patient impartiality. In the meantime, projects continue, each expedition a small act of listening. A corer pulled from a drowned estuary may reveal a centuries-long band of burnt pollen. An ROV camera may find a scatter of stone. Anchors lying quiet in silt, an ancient DNA assay may whisper the unexpected presence of domesticated barley in a layer that predated known agriculture in the region. Each signal alters probabilities, refines models, and widens the scope of human possibility. Taken together, these efforts do not promise immunity from catastrophe. They do, however, supply the tools of foresight, the ability to see, in the sedimentary ledger, precedents for events we fear, and thereby raise the odds that the next generation will make different choices. The last image is not an idyllic revelation, but a sober aperture. The ocean will hold its memories whether or not they are read. Work to map, sample, and interpret those memories is an act of stewardship, scientific, civic, and moral. If humanity wishes to avoid repeating some of the great erasures recorded in mud and stone, it must first be willing to ask the sea to be a teacher rather than a source of resources, and then to listen long enough to learn. What first struck observers was an image more than an argument, a distant ping returned from a sonar dome, a pale ridge appearing on a screen like a sentence half-formed. That synthetic echo, electronic light marking a place where light itself never reaches, became the emblem for the last phase of inquiry. Machines had begun to read parts of the ocean that human eyes could not see for more than a heartbeat. Autonomous vehicles hummed along silent corridors, tethered cameras descended into blue-black stillness. Rotors and manipulators brushed at encrusted stones, and piston corers drew up rolled cylinders of mud that were older, by many measures, than any single civilization's memory. The technology of mapping, of sampling, of robotic inspection opened new pages. Yet the narrators of this speculative documentary insist upon one clarifying image. What the machine surfaced is, so far, the visible tip of an enormous, unknowable iceberg. That iceberg is both literal and conceptual. On the map it is the geometry of shelves, terraces, buried river mouths and drowned deltas that read as places where people once lived. It is the vast black of abyssal plain where nodules accrete over millions of years. It is the scalloped outline of continental margins that have shifted with glacial rhythms and tectonic patience. Conceptually, the iceberg is the difference between what can be detected by current instruments and what remains hidden because of preservation biases, sampling sparsity, and sheer scale. Machines extend the senses, they do not, overnight, convert silence into a full narrative. The things they reveal are consequential, tantalizing, often ambiguous, and, above all, partial. The drama of discovery plays out in two rhythms. One is forensic and procedural, the slow choreography of a survey ship making a grid of multi-beam lines, an AUV flying at constant altitude, sub-bottom profilers stamping the buried strata like X-rays, a corer descending, latching, and drawing up a column of history that will be split in the laboratory like a book opened at the spine. The other rhythm is existential, the quiet rush that accompanies the sight of an alignment on a screen. The stirring when a core contains a band of soot where none had been expected. The small gasp at a DNA signature of an introduced plant species in a horizon that predates its assumed timeline. Those two tempos, method and wonder, cannot be separated. One tempers the other. Both are necessary. Machines provide evidence, and human imagination furnishes hypothesis. The tension between them produces knowledge that is both humble and expansive. Machines have, in recent years, transformed what was previously mere speculation into testable vectors. Sonar raises the contours of submerged terraces and ancient shorelines that once were walkable plains. Sub-bottom profilers indicate buried channels and estuarine fills where human settlements are most likely to have clustered. High-resolution coring retrieves laminated sequences, annual or seasonal layers that can preserve soot, pollen, and molecular biomarkers. Remotely operated vehicles can photograph alignments of dressed stones, anchors, or other anomalies without disturbing their context. Mass spectrometers, isotope labs, and ancient DNA facilities turn minute fragments into narratives of diet, metallurgy, and migration. The toolkit is formidable and growing. Still, the narrator insists on a cautionary refrain: detection is not equal to interpretation. The ocean is selective. It preserves in some places and erases in others. It is an archivist with preferences determined by chemistry, current energy, and burial speed. Anoxic black mud will conserve wooden artifacts and organic molecules, but it is rare and localized. Energetic coasts grind timber and bone into uninformative detritus. Tectonics can bury a coastline so deeply or recycle it so thoroughly that no trace survives beyond an isotopic whisper. Preservation is a lottery. The odds are stacked in favor of materials that resist chemistry stone, certain ceramics, and, increasingly, synthetic compounds of the modern era. The practical meaning is stark. Even a civilization of substantial complexity might leave only the faintest chemical residues if it relied on perishable materials or occupied regions where currents and waves are aggressive. There is a further layer of selection, sampling bias. The ocean is vast. Each core is a needle in a hayfield. The multi-beam surveys that now lace the coastal margins still leave great gaps in the deeper, more remote shelves. Research vessels are expensive to operate. The priorities of funding and politics dictate where they go. Where many cores have been extracted, patterns can be teased apart. Where cores are few, imaginative reconstructions risk outpacing evidence. The sleeping cities, if they sleep at all, may be clustered in pockets where the conditions for preservation and discovery converge: a drowned estuary capped by anoxic mud, a restricted basin with laminated sediments, a terrace that coincides with a paleochannel. The remaining unmapped parts of the shelf might hold other secrets, but they will not reveal them without patient, targeted effort. The technology, moreover, has revealed a paradox. Sometimes the clearest signs of human presence are not architectural silhouettes, but chemical legacies. Lead isotopes, spikes of soot, enriched levels of particular metals, and persistent organic molecules can indicate large-scale metallurgy, mass combustion events, or industrial behaviors that are otherwise invisible in the structural record. Sedimentary ancient DNA can whisper the adoption of domesticated grains, the shift in animal subsistence, or the arrival of foreign species. These proxies require calibration and replication, but together they form a forensic grammar that, when multiple lines converge, can support claims of significant human activity even in the absence of monumental ruins. The ocean thus often keeps the biography of societies in its chemistry more reliably than in their stones. Reaching that point of convergence is the work's central art. It demands multidisciplinary collaboration. Paleogeographers who reconstruct paleoshorelines, sedimentologists who interpret depositional pulses, paleobotanists who read pollen spectra, geochemists who decode isotopic excursions, geneticists who parse fragmentary ancient DNA, and maritime archaeologists who understand the material culture that might be expected at a particular time and place. The machinery of science is therefore social as well as technological. Discovery is a choreography of experts, each translating different dialects of the seafloor's record into a shared storyline. Where the conversation succeeds, the narrative moves from possibility to probability to explanation. Where it fails, hypotheses remain attractive but unproven. The narrator returns, inevitably, to the stories that humans tell about loss and drowning. Atlantis, the Black Sea flood legends, the memory-turned myth of Doggerland, the submerged rack of ports like those off Gujarat, the steppe-like ambiguity at Yonaguni. Those narratives matter because they preserve the shapes of catastrophe in cultural minds. They matter also because they warn. That myth can both preserve memory and reshape it. Myth asks the same questions the machines ask, but it answers them in a different register: moral, communal, existential. The job of modern inquiry is not to debunk myth so much as to translate it, when possible, into testable claims. Where did shorelines move? How quickly did inundation occur? What chemical fingerprints changed in tandem with the events that could have produced the memories? Sometimes the cultural memory and the geological record align, sometimes they do not. Both outcomes are instructive. The story, the machines, and the people who read them have begun to assemble has several recurring themes. One is fragility. Cities and ways of life that appear stable on human timelines can be fragile in the face of sea level change, tectonic movement, or climatic shifts. What looks permanent, an embankment, a harbour, an entire littoral economy, may be ephemeral on centennial timescales. A second theme is contingency. Whether a particular human imprint survives for the ages depends on chance alignments of material, choice, sedimentation rate, chemistry, and geography. A third theme is amplification. Even modest human activities, when aggregated, can leave detectable signatures in sediments. An early ironworking area concentrated near a river mouth, the long-term emission of soot from widespread burning, or the intensified harvesting and stocking of marine species that shifts local ecological baselines. These amplifications, faint in their moment, can leave disproportionate traces over long time. There is also an ethical current woven through the technological promise. The same instruments that reveal the seafloor's archive are beginning to be deployed for extraction. Interest in deep-sea minerals, the pressure to license seafloor mining, and the industrial capacity to disturb laminated sediments pose a profound dilemma. The act of removing nodules or scraping sulfide deposits will churn layers that record past climate, ecological transitions, and possibly human presence. Where geology preserves past events in thin bands, industrial disturbance will mix them irretrievably, erasing pages from the planetary book before they are read. The narrator frames this loss not only as environmental damage, but as a loss of knowledge. To destroy an archive before sampling it is to decide that short-term gain outweighs the long-term intelligence that might help. Humanity navigate the future. That future, in some sense, is what this entire inquiry is about. The sedimentary lessons from past inundations, from abrupt salinity shifts, from pulses of combustion and metal usage, are not trivia. They are empirical data on how the Earth system responds to forcing, climatic, volcanic, cometary, or anthropogenic, and on how societies have responded. The past provides analogues, times when carbon spiked and oceans warmed, times when coasts migrated inland, times when ecosystems reorganized around new baselines. Those analogues are imperfect, but they are critical. They expand the set of possible outcomes and the range of plausible response strategies. In a world where sea levels are again rising and where coastal populations number in the hundreds of millions, such knowledge is not optional. The conclusion, then, must be both a humility and an imperative. Humility, because the ocean's archive is partial, because detection is filtered by preservation bias, and because the absence of evidence in one place does not prove absence everywhere. Imperative, because the technologies that reveal the archive are also the tools of stewardship or of destruction, and because the knowledge contained in submerged sediments and structures can inform present-day choices that either reduce risk or court. Repetition of ancient calamities. Practical steps, the narrator insists, follow clearly from those two pillars. More high-resolution mapping of continental margins should be prioritized, not for spectacle, but to identify paleo shorelines and depositional basins where preservation is likely. Targeted coring programs should focus on those locales, using contamination, averse protocols, and open data practices so that multiple laboratories can cross-validate results. Interdisciplinary teams must be built with an ethic of transparency and community engagement, including coastal communities whose pasts may be directly implicated. Governance frameworks should adopt precautionary principles before seabed mining is permitted at scale. Baseline scientific inventories must be completed to avoid erasing irreplaceable archives. International collaboration, because the ocean is not constrained by national borders, must be the norm, not the exception. There is a deeper cultural step as well. The image of sleeping cities should prod societies to expand what counts as heritage. Heritage is often imagined as monuments, temples, and texts. In the marine archive, heritage is also chemistry, pollen spectra, and molecular fingerprints. Protecting the past means protecting the conditions that allow these proxies to remain legible, the slow, anoxic burial of matter, the non-disturbance of laminated sediments, the conservation of estuarine basins. Valuing that kind of heritage requires patience and a willingness to invest in long-term scientific work that produces no instant spectacle but yields the durable counsel of the deep. Finally, the narrator returns to an image used at the opening, the iceberg. What has been found by the new sensors and machines is indeed part of a tip, luminous and dramatic. It must be celebrated for the way it rearranges probability and opens new hypotheses. But it must also be recognized for what it is not, a complete ledger. The sleeping cities might be many or few. They might be urban polities entombed beneath silt, or seasonal camps erased by currents. They might have left monumental stones or only chemical accents. The mission ahead is to read the ocean's partial ledger with patience, humility, and interdisciplinary rigor, and to do so in a way that preserves as much as possible of what lies unread. In that tension between revelation and restraint, there is a final human lesson. To search the seabed is to practice a certain modesty before time. Empires rise and fall, coastlines move, language phrase. The ocean archives are not repositories of human vanity, they are tests of human patience. The technologies now at hand enable an unprecedented listening. If humanity uses them to learn carefully, collaboratively, and with a mind to stewardship, the sleeping cities beneath the waves might wake only into the language of evidence and understanding. If instead horizons of profit precede horizons of knowledge, those cities will remain asleep forever, their last testimony swallowed by waves and by time. The choice, quietly and irrevocably, remains. The question that opened this inquiry: could entire human narratives be buried beneath the sea? Hangs now like a refrain at the edge of the final reel. It has been pursued not as a fairy tale to be proven, but as a set of plausible, empirically approachable hypotheses. Probes into chemistry, geomorphology, and the stubborn grammar of sediments that together translate deep time into legible patterns. In the arch of the previous chapters, the ocean revealed itself both as eraser and archivist. As generator of myth and as keeper of molecules, it offered sites where preservation is generous and others where it is cruelly stingy. The part that remains is, in some ways, the hardest: to reckon with what those patterns mean for human imagination, for science, and for decision-making in an era when the present is already writing its own stratigraphic signature. The narrative thread running through the seafloor's pages is not a tidy chronology of lost empires. Rather, it is a set of conditional truths. Where shorelines were long-lived, where rivers built deltas and then shut down into low-energy basins, where anoxia preserved organic matter, the ocean can conserve echoes. Charcoal bands, pollen shifts, metallic enrichments, even traces of domesticated crops embedded in ancient mud. In such spots, Doggerland's stony hearths became netted fragments dragged to the surface. The Black Sea's laminae recorded a salinity transition that might have terrified coastal farmers. Dwarka's submerged masonry and anchors framed a coastline slow. Migration, Yonaguni's terraces, forced careful tests of tectonic jointing versus human intent. Each locus taught a lesson about constraint, that preservation is never uniform, that what survives is rarely the whole story, and that myth can both mislead and preserve a kernel of truth. That kernel, the faint persistence of human action, is rarely a monument. It is chemical, spatial, cumulative. A rise in soot across a basin's layer may indicate widespread burning, a regional isotopic. Excursion in lead may imply metallurgical intensification. A sudden appearance of domesticated DNA in a pollen sequence could mean agricultural import. A band of slag near a drowned estuary might be the fingerprint of sustained production. If a complex society once stretched across a shelf and engaged in large-scale extraction, metallurgy, combustion, or agriculture, these are the kinds of signals it would most likely leave. The seafloor does not favour narrative grandeur. It favours process signatures that, when read with discipline, point back to human agency. This is why the search for submerged civilizations is less archaeological treasure hunt than it is forensic science at planetary scale. The routine of discovery has a procedural choreography. Ships lay down multi-beam swaths and sub-bottom profiles to reveal buried channels and terraces. Autonomous vehicles skim the dark to collect bathymetry at resolutions once reserved for coastal harbours. ROVs descend with lamps and manipulator arms, disturbing only the light and the immediate water as cameras frame alignments of block. Anchor, or anomalous concretion. Piston corers are lowered and winched upward, each core a rolled column of compressed seasons, each lamination a thin page of environmental testimony. In the laboratory, the cores are split, photographed, X-rayed, and sampled for microfossils, isotopes, biomarkers, and cedar DNA. Teams compare lead isotopes with known ore sources. They scrutinize microstratigraphy to discriminate storm pulses from tsunami. Layers. They model paleotopography to find where humans would have camped, farmed, and anchored their boats. Emotion threads through the method. Scientists feel that peculiar mixture of wonder and restraint, an excitement at the possibility of an anomalous soot band or a matched tephra, coupled with a professional wariness rooted in past false positives. Fishermen who bring odd shards to port bring with them, as well, a different kind of testimony. The proximate surprise that the sea can disgorge suddenly, a thing that speaks of human shaping. Communities living near drowned shorelines hold memories refracted through centuries of storytelling. That cultural layer can direct scientific attention with a generosity that is both practical and ethically charged. The public, meanwhile, often prefers the vivid image of a sunken palace to a graph of isotopic anomalies. The media hunger for narrative closure pushes the science toward dramatic phrasing even when the record is cautious. Throughout this long inquiry, such pressures have been managed by method, by insistence on converging lines of evidence, and by acknowledgement of uncertainty. The ocean's selective memory forces that posture. A site like Yonaguni shows how compelling geometry can be misread without stratigraphic context. Dwaka illustrates how myth and material may converge yet still require reservoir corrections and careful geomorphological mapping, the Black Sea demonstrates. How a basin's chemistry and lamination can preserve a transition that is locally abrupt and regionally variable. All three highlight a central methodological posture. Look for alignment, geomorphic mapping here. Evidence of abrupt sedimentation there, chemical or biological proxies in the same horizon, and be willing to let ambiguity remain until multiple instruments and independent labs point in the same direction. That posture has political and ethical implications that are no longer speculative. The same technologies that allow multi-beam seafloor mapping and precise coring are now being deployed for commercial prospecting and potential deep-sea mining. The sedimentary pages that might contain the signatures of past human activity are also repositories of manganese nodules and polymetallic sulfides sought by modern industry. The physical act of industrial extraction, scraping, dredging, plume generation will mix and disperse laminated sediments, destroy anoxic preservation conditions, and permanently erase the microlayers that record climatic pulses and human impacts. To tear the archive before reading it is to deprive future generations of the possibility of learning from the planet's own deep time experiments. This raises a practical imperative as much as an intellectual one. If the goal is to answer, even provisionally, whether a vanished civilization sleeps beneath the waves, a global program of mapping and targeted coring must be prioritized. The priorities are clear in shape. Map continental shelves at high resolution to locate paleo shorelines and drowned paleochannels. Identify low-energy basins and anoxic troughs where lamination is preserved. Carry out focused coring campaigns in those loci with rigorous contamination control, and cue interdisciplinary teams: geophysicists, sedimentologists, paleobotanists, archaeologists, geochemists, and geneticists to analyze cores in parallel. Open data practices must be central. Bathymetric grids, core logs, geochemical assays, and DNA results should be shared, so independent replication is routine. International governance particularly in international waters, should require baseline surveys before mining licenses are issued. The ethical logic is straightforward. Knowledge is fragile, and the act of extracting resources must not presuppose that archival reading can be deferred without consequence. But policy and technology alone will not suffice. There is a deeper cultural work to be done, to widen the conception of heritage beyond standing stones and written texts, to include chemical layers and molecular residues. The recognition that environmental proxies, soot layers, isotopic excursions, pollen shifts are part of human heritage reframes preservation as a scientific and civic duty. Coastal communities, indigenous custodians, and national bodies must be part of the conversation about what counts as the past worth saving. Treating mud and molecules as heritage is an awkward proposition for institutions built around monuments, but the stakes, knowledge about past responses to rapid environmental change, are existential in an age of accelerating climate impact. Perhaps the most profound consequence of this entire line of inquiry is existential rather than empirical. The ocean's archives, when read carefully, do not simply feed a catalogue of lost wonders. They threaten and soothe in equal measure. They threaten the comforting narrative of linear progress, that human achievements accumulate in ways that necessarily endure. They suggest, more often, episodic continuity disrupted by sudden or cumulative environmental forces. And they soothe by offering a cautious kind of counsel, in many cases. Humanity's past responses to inundation were mixed. Some populations adapted, some relocated, and some cultural practices persisted in altered form. The sedimentary record offers examples of resilience as well as collapse, which brings the question to its hinge. Will modern society discover, conclusively, the ruins of a lost industrial civilization buried in deep time beneath the waves? The rigorous answer remains. It depends on the evidence and on our will to seek it. Science has articulated clear markers that would make such a claim credible. Planetary scale stratigraphic anomalies in isotopes, widespread and synchronous concentrations of industrially significant elements or synthetic compounds at depths inconsistent with modern contamination, and a coherent array of archaeological artifacts and in situ architectural remains whose stratigraphic contexts withstand cross-checks. These are high bars, and rightly so. Extraordinary claims require extraordinary convergence. But there is a subtler and perhaps more consequential variant of the question. Even if no wholly novel, unanticipated industrial civilization is found, the ocean will still yield lessons about the limits of permanence. The coastlines of the past show that complex lifeways, networks of trade and ritual, and intensive craft systems can be profoundly ephemeral in the face of rising seas, tectonics, and climatic swings. That realization reframes the search not as a hunt for sensational confirmation, but as a retrieval of humility. It asks contemporary societies to recognize that their own traces, plastics, isotopic signals, radionuclides will be read by far future geologists. Those traces will have ethical weight. In the end, then, the ocean's secret is double-edged. It may conceal a chapter of human ingenuity that time has folded into mud. It certainly contains the chemistry of many episodes. That remade human geography. Whether or not machines and corers will one day pull up incontrovertible ruins of an ancient. Industrial culture is uncertain. What is certain is that the ocean preserves records that can recalibrate human sense of temporal proportion. That recalibration matters now. It demands that the instruments of discovery be deployed with a humility that balances curiosity. With stewardship, that governments delay extraction until baselines are established, that the public education about the sea shift, from sensational claims to an appreciation of sedimentary patience. The speculative documentary does not close with a dramatic unveiling of a sunken metropolis. It closes with a question that is at once scientific and moral. Will present generations act as readers, patient, careful, cooperative, or as extractors, hungry, rapid, dismissive, when they encounter the seafloor's pages? The ocean does not care which choice humanity makes. It will retain or erase according to chemistry and movement. Humans do care, and that care will determine whether the next centuries inherit a richer understanding of what it means to live on a shifting planet, or whether they will have burned and scraped the archive for short-term gain, leaving future voices nothing but erasure to interpret. So the answer to the original, haunting query remains open. The sea may well be hiding chapters of human history that, if recovered, would astonish, inform, and provoke. But finding those chapters will require more than technology. It will demand an ethic of listening, a commitment to international cooperation, and a willingness to privilege long-term knowledge over immediate profit. The ocean's pages are there, inked in soot, in isotopes, in pollen, in DNA, waiting for disciplined readers. Whether humanity will rise to that task, reshaping its stewardship of the planet to preserve and learn from those pages, is the question that remains at the water's edge. Not only will we discover what lies beneath the waves, but will we do so in time to learn from it?